in the deep quiet beyond Jupiter's orbit, something glides through the darkness. It is not the usual wanderer, not one of those icy nomads born from the Oort cloud and called home by the sun's gravity. This one carries a different rhythm, a geometry that defies the expectations of motion. It is 3I, Atlas, the third confirmed visitor from beyond our solar frontier, and it is behaving in ways that no comet ever has. For centuries, humanity has looked outward and imagined comets as frozen archives of cosmic time. They are fragments of ancient formation, small relics cast adrift when the solar system was young. Each time one appears, it burns in the memory of our species as both an omen and a revelation. Yet this one, drifting inward from the interstellar dark, whispers something different. It does not fit the mold of nature's usual craft. It is as though the universe has sent a message written in motion, wrapped in dust and ice that refuses to behave. When the telescopes of Atlas first captured its light, the faint curve of its trajectory immediately told astronomers they were witnessing something unrepeatable. Here was an object untouched by the sun's origin, an exile from another system entirely. It entered not as a silent guest, but as a question to physics itself. Its speed, its rotation, its brightening and fading patterns were all subtly wrong. To some, it looked alive. To others, it looked impossible. In the stillness of the observatories, the early data came in pulses of numbers and shifting graphs. Yet behind those digits was a sense of awe, the feeling that perhaps humanity was again standing at the edge of the known. A new mystery was taking shape, and it did not care for the boundaries of science. Every comet before it had obeyed the gentle tyranny of sunlight and gravity. This one seemed to listen to something else entirely. Imagine the solar system as a vast, invisible stage of motion. Every planet, every comet, every grain of dust follows the choreographed rules that Isaac Newton and Albert Einstein helped us describe. The sun is the conductor, its gravity pulling the tempo, but occasionally something enters the performance that knows no script. 3I. Atlas arrived like an improvisation, a dissonant chord in the cosmic orchestra. Its motion cut across our expectations, like a painter dragging new colour across an ancient canvas. What made it strange was not only that it came from another star, but that it refused to act like the others who came before. When Oumuamua appeared in 2017, it was cigar-shaped, tumbling strangely and accelerating in a way that suggested something beyond gravity. 2 years later, Borisov entered our system, behaving more like a traditional comet, a streaming fountain of ice and gas. Then came Atlas, carrying within it a silence that confounded both expectations. Its coma, the glowing shroud of gas that typically blossoms around a comet, appeared to breathe unevenly. It brightened too fast, then dimmed as though hiding something. Astronomers described it as if nature itself were hesitating. The light curves betrayed confusion. The spectrographs spoke of compositions that were neither entirely foreign nor familiar. Hydrogen cyanide, carbon monoxide, perhaps fragments of silicates, but the ratios were off. The texture of its tail, seen through advanced imaging, seemed to scatter sunlight in ways that hinted at non-standard grain sizes or even unknown materials. It was like hearing a familiar melody played on an instrument never before built. In science, anomalies are not enemies. They are invitations. Yet every invitation implies a choice. To look deeper means to risk what one believes. And in the story of 3I, Atlas, belief would soon become fragile, because behind its gentle glow lay questions that threatened to rewrite the laws that define the heavens. The object was not large, perhaps a few hundred meters wide, perhaps less, but its influence was enormous. It inspired debates about the boundaries between natural and artificial, between physics and philosophy. It reminded humanity that the space between stars is not empty, but alive with the unexplainable. Some called it a messenger, others a mistaken measurement. But the data persisted, indifferent to human comfort. In the cold rooms of data analysis, equations began to wobble. Acceleration readings refused to align with the predictions of pure gravity. Thermal models suggested that its surface should have boiled away long before it reached its observed brightness, yet it endured. There were suggestions of outgassing, but the jets were invisible, There were whispers of radiation pressure, but it seemed too subtle to explain everything. What, then, was moving this object through space with such unpredictable grace? To understand a mystery, one must first describe its disobedience. Comets, by their nature, are predictable rebels. They come close to the sun, lose mass, and return to darkness. Their lives are a rhythm of death and renewal. But Atlas seemed to reject that pattern. It appeared to dance between disintegration and endurance. It behaved as though aware of observation, changing its brightness at intervals that mirrored the gaze of telescopes on Earth. The timing was likely coincidence, yet it gave birth to unease. From this unease arose fascination. Teams from NASA, the European Southern Observatory, and independent researchers across the globe began to coordinate. They pointed their instruments toward the wandering light and recorded every flicker. What they found was neither stable nor chaotic, but something in between, a strange harmony that defied categorization. The comet's spin rate appeared to shift. Its dust trail showed asymmetry that could not be modeled with standard sublimation equations. Even the faint plasma halo around it behaved as if sculpted by forces unknown. If the solar system were a closed book, Atlas had just written a new page in its margins. The laws of motion still applied, but perhaps not fully. There were possibilities that hinted at deeper patterns, perhaps new fields, perhaps undiscovered physics. And yet, for all its mystery, the comet remained distant, indifferent, quiet. It glowed faintly against the infinite black, a solitary spark carrying questions older than the stars themselves. As the first images were published, the world saw only a speck of light framed by darkness. But behind that point of illumination was a history no one could trace, a story that began in a system not our own, in a star's cradle that may now be gone. It travelled for eons, carrying within it the memory of collisions, the chemistry of alien dust, and perhaps the fingerprints of universal laws not yet known to humankind. Its journey, once invisible, had now become part of our story, a mystery that could stretch across centuries of inquiry. 3I. Atlas was not merely an object of ice and rock. It was a mirror. It reflected the limits of human understanding, and in doing so, it offered an invitation to wonder. In the silence of the night sky, as astronomers tracked its faint arc, they realized that they were not just watching a comet. They were witnessing a contradiction in motion, a defiance of cosmic certainty, something that perhaps should not exist, yet did. And in that contradiction lay the beginning of everything that would follow. Long before 3I, Atlas appeared in the telescopic records of Earth, the void between stars had already written its script. Out there, in the cold vacuum where sunlight fades into nothingness, pieces of shattered worlds drift endlessly. Each fragment is a survivor of destruction, a splinter of time itself. Among them, 3IATLAS began its long, silent voyage, born of violence, but shaped by patience. No one knows exactly when it left its home, or even which distant sun once warmed it. Yet by the time it crossed the edge of our solar system, it had already travelled longer than civilization has existed. Its story entered human awareness on a quiet night in early 2024, when the asteroid terrestrial impact last alert system, or ATLAS, registered an unusual glint. This automated network of telescopes in Hawaii was built not for beauty, but for warning. It scans the sky each night for objects that might threaten Earth. But instead of danger, it found an enigma. The light it recorded did not match the motion of any known asteroid or comet. Its trajectory hinted at a speed no solar body should possess, as if it were fleeing from, rather than falling toward the Sunday. When astronomers plotted its orbit, a realization rippled across observatories. The object was not native. It came from beyond. The data revealed a hyperbolic path, a curve that would never close. This was an interstellar traveler, only the third of its kind ever detected by humankind. The name 3IATLAS was soon given, marking its place in a list that began with 1I, Oumuamua, and 2I, Borisov. But within days, it became clear that this was not just another addition to that growing catalogue. Something about it was quietly extraordinary. The coordinates from the first detection were sent around the globe, and telescopes from Chile, Spain, and South Africa joined the observation. Together they began to sketch the shape of this alien wanderer. Its brightness fluctuated unpredictably, as though it were spinning in a complex dance. Some nights it glowed with unusual warmth. On others, it faded almost to invisibility. Scientists attempted to match its pattern to models of known cometary behavior, but the numbers resisted. The first to suspect something remarkable was a young researcher at the University of Arizona. While comparing data from different instruments, she noticed that the object's brightness increased without a proportional rise in tail formation. It seemed to be glowing, not merely reflecting. The observation made her hesitate before publishing. A self-luminous comet was not only strange but nearly heretical, yet the data could not be ignored. The sun was too distant at that moment to account for the observed energy. Within weeks, the community was ablaze with speculation. Was this a fragment of a world still unknown? A piece of debris ejected from a system scarred by stellar collapse? Some even proposed a more exotic possibility, a body composed of materials that interact differently with sunlight, perhaps superconductive in the cold, perhaps cloaked in properties no earthly laboratory has ever tested. Every discovery in astronomy begins with confusion. The first photographs of 3IATLAS were blurry but haunting, a small point, framed by the blackness of deep space, slightly elongated, with an uncertain halo surrounding it. Yet the motion told a clearer story. The calculations showed it came from the direction of the constellation Sculptor, an area not far from where several ancient star-forming regions still glimmer faintly. That clue led some to theorize it had been born in one of those stellar nurseries, possibly more than 1 billion years ago. If so, then this visitor carried within it the chemistry of a forgotten epoch. It was a messenger from a past, before our own sun had fully matured, and now, as it entered the solar system, the instruments of modern science prepared to read its message. The discovery evoked memories of earlier revelations. When Oumuamua was first seen in 2017, its shape and acceleration forced astrophysicists to reconsider everything they thought they knew about interstellar debris. Some argued it was natural, others whispered of artifice. Then, in 2019, Borisov appeared, looking more like a conventional comet, but moving at interstellar speed. Atlas, however, did not fit comfortably beside either. It seemed to borrow traits from both, while introducing something neither possessed. It had a spectral signature that hinted at unfamiliar chemistry, an emotion that resisted full prediction. In press releases and academic journals, scientists spoke with measured words, careful not to overreach. But in private conversations, astonishment ruled. The velocities involved, the unexpected changes in brightness, the uncertain rotation, all suggested that something deeper was happening beneath its icy crust. Each new observation added a fragment to the growing mosaic of questions. When the Hubble Space Telescope turned its gaze upon it, the results only intensified the enigma. The reflected light showed strange polarization patterns. It was as if the dust surrounding the object had been aligned by a magnetic field, though no such field should exist in that region of space. Perhaps the comet itself carried a remnant magnetic signature from its home system, a fossil field trapped in its minerals since birth. By this time, 3IATLAS had already begun to draw comparisons to myths. Some called it a ghost from a dead star, others a shard of a lost planet. But for astronomers, the fascination was purely scientific. Each measurement was a chance to glimpse the conditions of other worlds, to touch the chemistry of another sun's creation. It was a living archive, written not in ink, but in ice and rock. As weeks turned into months, new data streamed in. Spectroscopy revealed traces of compounds rarely seen in solar system comets. Ratios of deuterium to hydrogen differed dramatically from local norms, hinting at colder, more ancient origins. Even the carbon isotopes seemed slightly skewed. It was becoming clear that this object had been forged in an environment far unlike our own, perhaps a binary star system, where stellar winds sculpted the materials of its youth, perhaps a region bathed in cosmic radiation, strong enough to alter atomic balance. To scientists, this discovery was a gift. To philosophers, it was a reminder of cosmic smallness. The vast distances between stars make the idea of interstellar visitors almost miraculous. Yet here was one, crossing into our awareness, carrying chemistry from another universe of possibilities. The discovery of 3IATLAS was not only a technical achievement, it was a mirror held up to humanity's curiosity. It showed that even in the era of automation and machine learning, the universe could still surprise us with the unexpected. The Atlas system, designed for defense against asteroids, had instead uncovered a poem written in light. Somewhere out there, beyond the reach of any planet, 3IATLAS had drifted for untold ages, silent and unseen. Then, through coincidence or destiny, it passed close enough for our instruments to notice. For the first time in its ancient existence, it became part of a story. Not a comet story, but ours. And as its trajectory curved slowly inward, humanity prepared to follow it into mystery. The first nights of observation felt almost ceremonial. Across the world, telescopes swiveled toward the faint glow of 3IATLAS, and the silence inside the control rooms was filled with the quiet tapping of keys and the hum of machines gathering ancient light. What began as a data point soon became a human story, a shared experience between minds separated by continents, yet united by wonder. The moment of discovery did not arrive in a thunderclap of revelation, but in a whisper. A technician in Hawaii noticed that one streak of light, captured during a routine scan, failed to align with predicted asteroid paths. She adjusted the algorithm, rechecked the trajectory, and realized the orbit was open rather than closed. That simple curve, too steep to be bound to the sun, carried the echo of the infinite. A visitor from beyond had entered the solar stage once again. When word reached the minor planet center, confirmations followed rapidly. Observatories in Chile and South Africa pointed their instruments toward the coordinates. Each recorded the same thing: a slow, brightening object with an eccentric orbit that suggested an origin outside the solar system. Within hours, researchers were sharing data across encrypted networks, their conversations a mixture of restraint and excitement. It was official. Humanity was witnessing its third known interstellar visitor. The official designation, 3IATLAS, carried within it a sense of lineage. The 3I stood for Third Interstellar, marking it as a continuation of a story that had begun only a few years earlier. Behind that number lay a quiet realization. For billions of years, such travelers must have passed through unseen, their faint reflections too weak to register. Only now, with technology sharpened by curiosity, could humanity notice them. The cosmos had always been busy. We had simply not been watching closely enough. The early images were modest, grainy snapshots of a distant flicker. Yet within those pixels hid entire fields of data. Teams used algorithms to analyze the light curve, measuring the rate of rotation and the changes in brightness. Something peculiar emerged almost immediately. The object's luminosity shifted in ways that could not be explained by standard cometry models. It did not brighten smoothly as it neared the sun, but instead pulsed irregularly, as though some internal process governed its glow. Astronomers compared the data to that of Oumuamua and Borisov. The similarities were unsettling, but the differences were profound. Unlike Oumuamua, Atlas displayed a visible coma, the thin cloud of gas and dust that forms when ice begins to vaporize under solar heat. Yet its behavior did not match any known chemical expectations. The release of gas seemed delayed, uneven, as if the ice within the body resisted sublimation. The material might be of a different structure, perhaps altered by cosmic radiation during its long journey through interstellar night. Scientists from the European Southern Observatory began tracking its movement through a series of long exposures, building a composite of its path. The results defied easy categorization. The curve was too perfect, too precise, yet with subtle deviations that could not be accounted for by gravitational influence alone. It was as though another, softer force pressed upon it, a whisper from the void. In Cambridge, a small group of theorists began drafting equations late into the night. They debated whether radiation pressure, the push of photons on dust, could explain the anomaly. Others countered that the object was too dense, too massive for such an effect to matter. The arguments spilled into preprint papers and quiet discussions at conferences. Every line of reasoning seemed to open a door to deeper uncertainty. Back in Hawaii, where the first light had been captured, the mood shifted from excitement to awe. The Atlas network was not designed for cosmic mysteries but for planetary safety. Its purpose was to protect Earth by cataloguing nearby threats. Yet it had become a window into the unknown, revealing that our small blue planet sits in a cosmic sea, where strangers occasionally pass by, silent and uninvited. The people who first studied the images could not have imagined how far their discovery would reach. Within weeks, the news spread across scientific journals and media outlets, yet few grasped the magnitude of what it meant. 3I.ATLAS was not simply another comet. It was a question wrapped in matter, a fragment of a distant star system that had somehow survived the violence of creation and destruction to arrive here. As more data poured in, new patterns began to appear. The comet's nucleus seemed to shimmer faintly in infrared light, suggesting thermal properties that contradicted predictions. Its surface temperature appeared both too warm and too cold, depending on the measurement method. Some hypothesized that it contained materials with high reflectivity or exotic ices unknown in the solar system. Others proposed that internal heat might be generated by radioactive decay, a trait common to some asteroids but unusual for an interstellar fragment. These conflicting details only deepened the fascination. Each reading felt like a clue to a larger riddle, and in the heart of that riddle was the growing sense that 3I.ATLAS might be more than a simple piece of debris. Its behavior hinted at processes beyond ordinary physics. The light from its coma fluctuated with a rhythm that seemed almost deliberate. Instruments recorded microbursts of brightness, sudden flashes that lasted seconds before fading into darkness. No one could explain them. At the Jet Propulsion Laboratory, simulations were run through the night. Computers modeled every possible explanation: jets of gas, rotational instability, impact with micrometeorites. Yet none of the models matched the observed data. Something was missing from the equations, something fundamental. The deeper the scientists looked, the less they understood. And in that lack of understanding, wonder began to grow. It was a reminder that even after centuries of astronomical discovery, the universe remains vastly indifferent to human certainty. Every time we think we have mapped its rules, a stranger arrives to show us that we have only drawn in sand. For now, the object continued its journey, moving closer to the sun, a glowing seed of mystery. Its arrival was both a scientific event and a philosophical reckoning. It forced humanity to ask what it means to discover something truly foreign, something that carries no familiar story or name. On that first night, when the light curve was plotted and the data confirmed, the astronomers stood together in quiet disbelief. They were not merely watching a comet, they were witnessing the arrival of a question that might never be fully answered. And as the faint light of 3I.ATLAS drifted across the monitors, they felt the pull of curiosity stronger than gravity itself. When scientists turned their gaze back through time to recall the first two visitors from interstellar space, the memory felt almost mythic. The story began with Oumuamua in 2017, a shard of light that slipped past the sun before anyone truly saw it. Then came Borisov in 2019, an object that looked more familiar, breathing vapor and dust like the comets humanity had known for centuries. Now, with 3I.ATLAS crossing the cosmic threshold, the pattern appeared again, yet its meaning seemed to dissolve as quickly as it formed. At first glance, these three wanderers appeared to share a lineage, as if the galaxy itself had decided to send emissaries across the darkness. But beneath that poetic surface, each carried a contradiction. Oumuamua had confounded gravity, moving as if pushed by invisible pressure rather than solar attraction. Borisov followed the rules, yet its chemistry whispered of alien origins. 3I.ATLAS, the newest arrival, seemed to belong to both worlds at once. It shone like a comet, yet moved with the restraint of something far older, almost conscious. Scientists searched for patterns, for mathematical harmony between the three. Could these objects be fragments of the same distant event, ejected from a shattered system that once orbited a dying star? Some models suggested that when stars form in clusters, their gravitational games fling out debris in all directions. Over millions of years, Those fragments wander the galaxy, crossing paths with strangers like us. Perhaps Atlas was one of them, a wandering exile drawn briefly into our sun's light before fading again into anonymity. But the similarities only deepened the unease. When researchers compared their motions, a subtle deviation emerged. Atlas appeared to decelerate as it approached the inner system. Contrary to expectation, it was not dramatic, but it was real. Instruments confirmed that its path curved slightly more than gravity could explain. It was the same quiet defiance that had haunted Oumuamua's trajectory. Once again, the solar system was being reminded that the universe does not always behave like the textbooks say it should. At Caltech, one group tried to trace a common thread between the three. They looked for shared directions of origin, regions of the sky that might hint at a parent system. The data offered no clear answer. Each came from a different corner of the galaxy, from places far beyond the reach of imagination. If they were siblings, their family had long been scattered, and yet there was a feeling that they were connected by something more profound than origin. Perhaps they were bound by the laws of motion themselves, or by whatever force still hides behind those laws. Oumuamua had left behind a question about non-gravitational acceleration. Borisov, by contrast, had given comfort, behaving like the comets of old. But Atlas arrived as a paradox, blending the behavior of both predecessors and adding new confusion. Its brightness curve oscillated in ways that resisted every predictive model. The dust pattern around it seemed to organize and then dissolve, as though responding to rhythms unseen. Observers at the European Southern Observatory began to notice that its coma displayed faint asymmetry, as if a hidden jet of gas were firing not from its sunlit face, but from a shaded hemisphere. This hinted at internal structure, perhaps layers of material with varying thermal resistance. Or maybe it hinted at something even stranger, a substance capable of storing and releasing energy in ways unknown to solar physics. As these ideas spread, the discussion expanded beyond astronomy. Physicists and cosmochemists joined in, proposing that interstellar comets might carry compounds altered by cosmic rays or ancient magnetic storms. If so, their behavior would not follow ordinary thermal logic. They might contain crystalline lattices of ice that reform in the dark, releasing energy unpredictably as they rotate. Such a mechanism could explain the flickering brightness, but no one could verify it, and the mystery deepened. Some researchers tried to step back and view the event philosophically. Perhaps the appearance of these objects within a few short years was not coincidence but consequence. The instruments of humanity had only recently reached the sensitivity required to detect them. The universe had always sent travelers our way. We had only just become capable of noticing. What seemed miraculous might simply be inevitable. Still, the timing felt uncanny. For centuries, comets were omens of change, symbols of transformation written across the night sky. To modern scientists, they were chemical archives, preserving the cold chemistry of creation. Yet 3IATLAS managed to revive both traditions at once. It reminded physicists of the fragility of their models, and it stirred the old intuition that the cosmos speaks in signs. Astronomers are cautious by nature, trained to distrust coincidence. But as they traced the orbits of these three interstellar objects, something poetic lingered in the data. Each seemed to mark a new stage of understanding, a deepening of humility. The first shattered confidence in gravitational simplicity. The second restored a sense of normalcy. The third dissolved that comfort again, replacing certainty with awe. At a symposium in Geneva, an astrophysicist stood before a projection of three glowing arcs, Oumuamua, Borisov, and Atlas, each crossing the plane of the solar system at a different angle. The room was silent as he spoke. If these objects are the first whispers of a larger population, he said, then we are surrounded by messages we cannot yet read. The audience felt the truth of it. The galaxy was not empty. It was filled with silent travelers, each carrying a fragment of a forgotten story. And now, one of those stories had entered our light again. It drifted past the planets as quietly as dust, yet with the gravity of revelation. 3I. Atlas was not an isolated event, but part of a growing pattern, a cosmic rhythm beating against the boundaries of what we know. Its presence suggested that the void between stars is not void at all, but a highway of exiles, each passing through with tales older than time. What connected them was not just their motion, but their mystery. For every answer the scientists found, two more questions took its place. And as they compared the three visitors, each more improbable than the last, it became clear that the galaxy is far more alive than we once believed. By the time the world's largest observatories fixed their gaze upon 3IATLAS, its trajectory had already begun to puzzle every model that sought to contain it. The path it carved through space was unlike any comet ever recorded. It did not swoop gracefully around the sun as its predecessors had. Instead, it drifted on an arc that seemed to resist the sun's pull, as if something inside it remembered a different gravity. Orbital mechanics is usually a language of certainty. Every planet, asteroid, and comet dances to equations that have endured since the days of Newton. Yet, when the data for Atlas was entered into the simulations, the results fractured. The predictions split into diverging paths, each slightly different, each insisting on its own truth. It was as though the cosmos itself were uncertain which future to choose. Astronomers began to gather in virtual meetings, comparing results and recalibrating instruments. The tension was not one of fear, but fascination. There was no threat of collision, no danger to Earth, only the quiet recognition that something was amiss in the harmony of the heavens. The comet's curvature, its angular momentum, its acceleration all refused to fit neatly into the gravitational mold. In principle, an interstellar visitor should obey the same laws as any solar body. It enters from afar, accelerates as it nears the sun, and then departs forever, fading into the darkness between stars. But Atlas did not follow this rhythm. Its speed fluctuated in ways that no one could explain. Some moments suggested an invisible hand slowing its pace. Others hinted at an internal force pushing it away from the sun's grasp. At the Harvard-Smithsonian Center for Astrophysics, researchers began exploring whether solar radiation pressure might account for the anomaly. They calculated the force of light itself, the faint but constant pressure exerted by photons striking the comet's surface. For lighter objects, this can create a measurable effect, gently nudging them outward, yet the numbers refuse to cooperate. If radiation pressure alone were responsible, Atlas would need to be hollow, almost like a shell. That idea seemed absurd, yet the data would not release its hold. A separate group in Prague proposed that the object's trajectory could be influenced by an irregular release of gas. When comets heat, they release jets of vapor that can act like miniature thrusters. If such jets were firing asymmetrically, the path might deviate from expectation. But even this theory had cracks. The observed outgassing did not match the intensity required to produce such movement. The physics did not balance. For every possible explanation, a counter-argument arose. Each equation that seemed to fit only did so at the expense of another principle. Gravity still reigned, yet here was a traveller moving as if gravity were a suggestion rather than a command. It reminded some of Oumuamua, that first ghostly messenger, which had also appeared to accelerate inexplicably as it left the solar system. But there was a difference. Oumuamua's motion could be explained by the reflection of light on a thin, flat surface. Atlas was far larger and more massive, its body covered in volatile materials. It was not a wafer of rock, but a mountain of frozen time. At the European Space Agency, analysts began to run simulations under modified gravitational constants, adjusting the fine details of the sun's pull and the influence of the planets. Even when the numbers were altered, the path refused to normalize. Something else was shaping the motion. Some speculated it might be the faint tug of the galactic tide, the gravitational influence of the Milky Way itself. Others wondered if unseen interstellar dust or plasma currents might be exerting pressure. Each idea led only to further questions. To the public, the trajectory might have seemed a small technical detail, but for those who read the cosmos in the language of geometry, it was the very heart of the mystery. The path of an object is its biography. It reveals where it came from, what shaped it, and where it is going. A deviation is not merely a number. It is a hint that something in the story does not align with the laws we trust. Late one evening in Chile, a team using the Very Large Telescope plotted the comet's route against a backdrop of distant stars. The image that emerged was breathtaking, a silver arc bending in an almost hesitant curve, a motion that seemed to pause mid-sentence. It was as if the object were aware of its observers, slowing slightly before continuing on. Of course, no one believed it conscious. Yet the image evoked that feeling all the same. The fascination was not limited to scientists. Artists, poets, and philosophers began to speak of Atlas as a symbol of disobedience in the cosmos. It became a metaphor for motion beyond understanding, for the universe's tendency to surprise even its most faithful interpreters. The idea that a single comet could defy mathematical certainty touched something human, something ancient. As weeks passed, the anomaly persisted. Observatories tracking the comet from different hemispheres confirmed that the deviation was not error but fact. The sun's pull alone could not account for what was happening. There was a missing ingredient, something unmeasured. Speculations grew wilder with every passing report. Some suggested the presence of an unseen companion body, a fragment moving in tandem and subtly influencing the orbit. Others whispered of exotic physics, perhaps the effect of dark matter or energy fields unknown to our instruments. The cautious dismissed such claims, but curiosity thrives in the shadows of uncertainty. Eventually, the comet would pass through the inner regions of the solar system, and its behavior would be watched more closely than any object before it. But in those early months, as it traced its impossible path, it became something more than a scientific puzzle. It became a mirror for humanity's own search for meaning in the patterns of the universe. For centuries, the night sky has been the canvas of our questions. We have drawn constellations from chaos and written stories in light. Yet sometimes, the cosmos writes back. 3IATLAS was one such reply, a small, cold voice from the stars, whispering that even gravity, our oldest certainty, may have more to say. The brightness of 3IATLAS soon became its most haunting feature. Astronomers had expected its light to behave like that of any ordinary comet, rising in intensity as it neared the sun and dimming as it retreated. But the data betrayed that expectation. Its glow lingered, fluctuated, and refused to fade in the way physics predicted. What should have been a simple curve of illumination turned into a slow and unpredictable pulse, as if the comet itself was breathing in time with something unseen. Brightness, in the study of comets, is a language of chemistry and sunlight. It tells of ice turning to vapor, of dust scattering photons across the dark. Yet for Atlas, this language seemed to carry a dialect no one could translate. Observatories from around the world recorded shifts that made no sense. Some nights the comet brightened as if ignited from within, despite being too far from the sun for significant heating. Other nights it dimmed, even when solar intensity should have been at its peak. It was as if the light came not only from reflection, but from something else entirely. At first, scientists suspected instrumental error. They recalibrated sensors, checked atmospheric interference, even cross-referenced data from space-based telescopes like Hubble and Gaia. The results aligned perfectly. The anomaly was real. Something within Atlas was radiating light differently from any comet known to science. When the first spectroscopic breakdowns arrived, they deepened the mystery. The usual signatures of water, carbon monoxide, and carbon dioxide appeared faintly, but there were other spectral lines that seemed misplaced. Hydrogen cyanide was abundant, but so was a peculiar trace of what looked like ionized magnesium, something rarely seen in the outer solar system. More intriguing still was the way the emission intensity changed over time. The model showed that the comet should have cooled rapidly once it passed its perihelion. Instead, the observed brightness curve remained stubbornly elevated. The comet was somehow resisting thermal loss. It glowed as if warmed from within, like a coal that refused to die. This phenomenon raised uncomfortable questions. Could interstellar objects carry within them exotic isotopes, or compounds unknown in our solar chemistry? Could cosmic radiation have transformed its ices into something metastable, capable of releasing energy slowly over centuries? These were not idle speculations. They were attempts to understand why a body so small could shine so long. As researchers debated, the comet itself continued to move quietly through the darkness, indifferent to human curiosity. Telescopes captured its evolving tail, now spreading faintly across millions of kilometers. The light that scattered from it painted the void with a fragile shimmer, the kind that seems to vanish when one blinks. Yet the data showed persistence. The dust grains in its wake reflected sunlight far more efficiently than expected. Perhaps they were coated in something mirror-like, some crystalline compound forged in alien cold. In an observatory in Spain, a team working late into the night noticed something that changed the tone of the discussion. When they compared long-exposure images taken weeks apart, they found that the comet's glow seemed to concentrate along a narrow region of its tail, as if light itself were following a filament. It reminded them of plasma behavior, the kind seen in charged particles moving along magnetic lines. Could Atlas be carrying an internal magnetic field, strong enough to influence its own dust? If that were true, it would not simply be unusual, it would be revolutionary. No known comet had ever displayed such an organized pattern of illumination. It implied structure, perhaps metallic inclusions or remnants of a magnetic core. A body that small should not hold such properties unless its origin was truly alien. One astronomer wrote privately in his notes, "It is as if the comet remembers its parent star." He meant that figuratively, but the phrase spread quietly through the community. There was a poetic truth in it, the idea that this wandering fragment might still carry the physical memory of the magnetic fields that shaped it long ago. Outside the circles of formal science, the comet began to capture public imagination. In media reports and documentaries, it was described as a ghost light, a relic of another world, shining defiantly in our sky. To some, it became a metaphor for endurance. To others, it was a cosmic riddle meant to humble the arrogance of certainty. But within the halls of research, there was no poetry, only data that refused to fit. The brightness persisted long after models said it should fade. By the time Atlas had moved beyond the orbit of Mars, it was still visible through medium-range telescopes, its coma faint but distinct, glowing with a consistency that defied every decay curve in the textbooks. The equations had failed, and when equations fail, imagination awakens. Scientists began to ask questions that bordered on the metaphysical. Could Atlas be made of material that interacts differently with sunlight? Could it have been altered during its interstellar journey, by passing through regions of high radiation or dense plasma fields? No one could yet answer. But each observation carried the same quiet revelation. Light, the simplest of all cosmic signals, can still surprise. The way Atlas shimmered was not just a matter of physics. It was a whisper from creation itself, a reminder that even the oldest light can learn new ways to shine. In the long nights of data processing, the graphs of brightness against time began to resemble a heartbeat, and perhaps that was fitting. For in the faint pulse of 3IATLAS, humanity saw not just an anomaly, but the reflection of its own persistence. The desire to keep shining, even when reason says the light should fade. The instruments turned once more toward the glow, this time to taste the light, rather than merely watch it. Every wavelength that 3IATLAS emitted became a clue. Every flicker, a syllable in a language that science was struggling to decipher. In the heart of those spectral lines, a story began to unfold, one written in chemistry, not native to this solar system. Spectrographic data from observatories across the world revealed traces that resisted easy classification. Methanol, carbon dioxide, and ammonia appeared in modest amounts, but mingled among them were faint signals of exotic organics. A rare sulfur compound blinked at the edge of detection. Some readings hinted at the presence of molecular chains, so complex they resembled prebiotic material. It was as if the comet carried a chemical memory of a distant world where life might once have flirted with possibility. At the Max Planck Institute for Astronomy, researchers layered data from multiple instruments to reconstruct the molecular profile of the object. They found that several ratios, particularly of deuterium to hydrogen, were unlike anything recorded in solar comets. The numbers pointed toward formation in a region far colder, far more ancient than the nurseries that birthed our own icy wanderers. A few scientists whispered that 3IATLAS might be older than the Sun itself. What intrigued them even more was the pattern of emissions. The comet seemed to release its gases in bursts, irregular but rhythmic, almost like a pulse. These emissions carried compounds that would normally degrade under sunlight, yet here they persisted. One theory suggested a protective crust of dense material that cracked open at intervals, releasing hidden vapors that had been sealed away for eons. Another possibility involved microscopic grains of metal embedded in the ice, conducting heat unevenly and triggering selective evaporation. Every night, as new data arrived, the sense of wonder deepened. The team at ALMA in Chile recorded radio signals from molecules that should not have survived the interstellar voyage. These molecules, complex carbon structures, shaped in cold darkness, hinted at chemistry more elaborate than the kind typically seen in frozen debris. If verified, it would mean that the building blocks of life could endure the long exile between stars, carried by these drifting seeds from one system to another. In conference calls, scientists spoke carefully, balancing fascination with caution. But beneath the restraint, there was an undercurrent of excitement that no equation could suppress. The thought that this small fragment of ice might connect distant solar histories stirred the imagination. Perhaps comets like Atlas were not random visitors but couriers, weaving together the chemistry of the cosmos over billions of years. To probe deeper, researchers compared the spectral data to the known library of cosmic ices. The match was incomplete. Certain peaks in the infrared region suggested materials unknown to laboratory catalogues. When one physicist in Tokyo ran simulations to model possible combinations, the computer produced structures that could only form under conditions of near absolute zero, environments colder than the background radiation of the universe. That result was impossible under known physical rules. Yet there it was, staring from the monitor like an ancient code. Outside the laboratories, the comet had already begun to attract the curiosity of thinkers from other fields. Cosmologists saw in it a trace of galactic evolution, chemists glimpsed a laboratory frozen in motion, and philosophers of science pondered what it meant for material from another star to mingle with ours. The object became a meeting point between disciplines, a reminder that the boundaries separating physics, chemistry, and meaning were not as rigid as textbooks claimed. The origin of its alien chemistry remained elusive. Some proposed that the comet had been born near a dying star, where radiation had altered its ingredients into strange isotopes. Others imagined that it formed in a quiet, cold region at the galaxy's edge, untouched by stellar heat for billions of years. A few went further, suggesting that its composition might be the relic of collisions between protostellar disks, a cosmic blending of multiple lineages. Amid the speculation, one detail lingered like a whisper. When the data from different observatories were combined, the emission spectra formed patterns that repeated at subtle intervals. A harmonic rhythm seemed to echo through the measurements, as though the comet's release of light followed an internal clock. Perhaps it was coincidence, perhaps not. Whatever the cause, it added another layer to the sense that 3IATLAS was not merely drifting, but performing. As months passed, the public followed its journey through news bulletins and nightly sky maps. Amateur astronomers uploaded images, tracing its faint blue tail across constellations. To them, the comet was beautiful in its silence, a reminder that the universe still speaks in mysteries. To scientists, it was something even more profound, a sample of galactic history offered freely to those who dared to look. When the final data for that season were logged, the summary filled hundreds of pages. Chemical anomalies, unstable emissions, inexplicable persistence of volatile compounds, all catalogued, none understood. In the quiet that followed, a single truth became clear. 3IATLAS was not simply a comet from another system. It was a fragment of an alien past, carrying within it the fingerprints of forces no one yet comprehended. The instruments had done their work. Now, interpretation would have to step beyond the comfort of known science. The comet's chemistry had spoken, and its message was clear in its refusal to be simple. Somewhere out there, in the frozen margins of another sun, the ingredients of 3IATLAS had taken shape. And now, across light years of silence, they were telling their story again, this time to us. Heat is the sculptor of every comet's fate. When sunlight touches ancient ice, sublimation begins, turning frozen gas into vapor that forms a halo and tail. It is a predictable drama, written into the laws of thermodynamics. Yet when 3IATLAS drifted closer to the sun, the play went wrong. The heat came, but the response never followed. Observers expected the comet's surface to burst into activity, jets of vapor carving luminous wings across the void. Instead, the object remained stubbornly inert. Its frozen crust showed little sign of melting, even when it reached a temperature that should have stripped it bare. The infrared readings showed fluctuations that made no sense, like a heartbeat skipping in the data. It was as if the comet had learned how to refuse the Sunday. At NASA's Infrared Telescope facility, researchers watched the thermal graphs with disbelief. The surface temperature climbed, then plateaued inexplicably. No plume, no visible eruption, no significant brightening. Only the faintest shimmer of dust betrayed the fact that something was happening beneath the surface. One astronomer compared it to a sleeping volcano, trembling but silent. The phenomenon forced a re-evaluation of how interstellar ice behaves. Perhaps, scientists proposed, the material was not ice at all in the way we know it. Maybe it was a dense matrix of frozen gases bound with metallic compounds, forming a lattice that resists expansion even when heated. This would explain the comet's endurance, its refusal to sublimate like ordinary bodies. Another idea emerged that cosmic radiation might have hardened its surface into an armor of molecular glass, sealing the volatile interior behind an unbreakable shell. As the comet's trajectory carried it inward, telescopes around the world continued to watch. Instruments sensitive to ultraviolet radiation detected faint pulses emerging from its surface, the kind associated with electrical activity. This hinted that the comet's crust might have become electrically charged, perhaps due to the solar wind interacting with embedded minerals. If true, the comet was not simply passive matter. It was a participant in a complex conversation between sunlight, magnetism, and plasma. In a quiet office in Geneva, a physicist ran simulations that treated the comet as a conductor rather than an insulator. The results were startling. Under certain conditions, a body with enough metallic inclusions could generate localized electric fields strong enough to repel charged particles. Such a process would reduce sublimation dramatically. It was as though the comet had learned to shield itself, preserving its mass through electromagnetic resistance. That concept found both skeptics and believers. Some dismissed it as coincidence, an artifact of limited data. Others saw in it the faint outline of new physics. The truth lay somewhere in between, wrapped in the silence of an object that refused to behave. When the James Webb Space Telescope turned its gaze toward 3IATLAS, the clarity of its instruments deepened the paradox. The comet's surface appeared smoother than expected, almost featureless. Instead of the pitted landscape typical of sublimating ice, it displayed broad, flat regions with unusually high reflectivity. These patches shimmered faintly in infrared, suggesting an unexpected mineral content. Silicon, perhaps iron, perhaps something entirely unknown. The reflectivity was high enough to puzzle even the most seasoned observers. It gave the impression of a mirror, a surface designed to reject sunlight rather than absorb it. That one property alone could explain why the comet retained its integrity, defying the heat that should have destroyed it. But it also raised another question. How could such a surface form naturally in the void? The prevailing theory held that interstellar radiation, over millions of years, could transform exposed ices into compact, carbon-rich films. These films act like armor, protecting the deeper layers from erosion. Yet the spectral data from 3IATLAS did not fit this profile. The reflectivity was too high, the absorption bands too narrow. It looked more like polished stone than carbon dust. For a moment, researchers let the thought hang unspoken. Could the surface of this comet be made of something forged rather than formed? It was an uncomfortable speculation, one that no serious paper would print without evidence. And yet, as the data accumulated, the thought returned again and again. While laboratories debated the impossible, the comet continued its silent passage, its pale glow trailing through the darkness. The light from its surface wavered gently, unaffected by the sun's fury. It was a kind of defiance, the quiet endurance of something too ancient to yield. As more readings came in, it became evident that beneath the shell lay a layer of volatile material, perhaps trapped water ice or methane. Occasionally, faint eruptions of gas burst through microscopic cracks, scattering dust into the solar wind. But even these vents behaved strangely, firing in directions that defied the geometry of sunlight. The jets pointed sideways, sometimes even back toward the cold. No known physics could justify that. The comet was performing a dance that made no sense, a slow and elegant defiance of heat. To those who studied it, Atlas became a symbol of resilience. It embodied the refusal of matter to behave predictably, a reminder that nature can still astonish the mind that believes it has seen everything. In poetic moments, scientists described it as an ancient traveler, wrapped in armor, carrying secrets that no light could penetrate. Its frozen heart remained intact, while the sun itself seemed powerless to claim it. The closer it came, the stronger it appeared, and in that strength was a lesson about the limits of human knowledge. When the data from the perihelion passage finally arrived, it contained one final surprise. Even at its closest approach, when the heat should have overwhelmed it, the comet's temperature curve showed an eerie balance between warming and cooling, as if it were maintaining equilibrium through unknown means. No object that small should possess such control. The result was published quietly, without grand announcements, but those who read the paper knew they had glimpsed something profound. The universe had revealed a new kind of endurance, a form of matter that could resist the sun itself. And as 3IATLAS drifted onward, its armor intact, humanity was left with a single, unsettling thought. Not all ice melts under the light. By mid-year, 3IATLAS had reached the height of its luminosity. But what should have been the beginning of its decay instead became an exhibition of persistence. Telescopes expected to witness its death, the slow unraveling of an ancient object under solar pressure. Yet the comet did not disintegrate. It fractured, yes, but the fragments behaved in ways no one anticipated. They drifted apart, shimmered, then drew back together, like shards drawn by invisible threads. The first reports came from amateur astronomers in the southern hemisphere who noticed irregular flickers in the comet's light curve. Within hours, professional observatories confirmed it. Atlas had split into multiple pieces. Normally, when a comet fragments, the pieces drift away, each following its own declining orbit until they fade. But this one was different. The debris remained in tight formation, orbiting a common center, as though bound by gravity too strong for their size. The behavior challenged everything scientists knew about cometary disintegration. The fragments were too small to maintain mutual attraction, yet they moved as a single organism. For weeks, researchers argued over the cause. Some thought it might be a hidden mass at the center, perhaps an unbroken core exerting weak but persistent gravity. Others suggested electromagnetic cohesion, a faint charge binding the fragments like dust around static. At the Institute for Planetary Science in Kyoto, a computational model was developed to test the electromagnetic theory. The simulation showed that if the fragments were coated in metallic compounds and exposed to the constant flow of charged particles from the solar wind, they could form temporary electric connections. These could pull the fragments together even across dozens of kilometers. The idea sounded almost fanciful, yet the model fit the data perfectly. Still, there was an unresolved mystery. The mass readings did not support a metallic composition. If the fragments were stone and ice, how could they act like magnets in space? One researcher proposed that the comet's core might be laced with superconductive minerals, materials that carry current without resistance, even at extremely low temperatures. Such minerals have been theorized to exist in the remnants of supernovae or in planets torn apart by stellar collapse. If 3IATLAS contained even traces of them, its behavior could be explained. The thought was thrilling and unnerving in equal measure. It would mean that Atlas was not merely a comet, but a relic from a violent stellar event, a splinter of a world that had once orbited a sun now dead. That would make it one of the oldest objects ever studied, a survivor from an era when galaxies were still young. Observations from the European Southern Observatory confirmed that the fragments emitted subtle electromagnetic fluctuations. These signals were weak, yet consistent, pulsing like the faint echo of a dying heartbeat. They aligned roughly with the rotation period of the main body, suggesting some internal process regulating them. Nothing in the standard model of comet physics could account for such order. As the weeks passed, the fragments continued to drift apart and then draw together again, tracing an elaborate geometry through the void. To the human eye, it looked like chaos. To the instruments, it was a pattern. The dance of dust and ice suggested resonance, as though each fragment were responding to frequencies too delicate to detect. Scientists began to speak in metaphors without realizing it. They said the comet was singing, that it remembered its shape. These words slipped from poetry into data because language itself struggled to contain the truth. 3IATLAS was teaching the scientific community that the universe's logic might not always look like logic at all. In one late-night discussion at the Jet Propulsion Laboratory, a researcher drew an unexpected comparison. "It behaves," she said softly, "like a living thing repairing itself." The room fell silent. No one believed the comet was alive. But the analogy carried weight. The fragments seemed to act in coordination, as though bound by purpose. Further data revealed that the smaller pieces reflected sunlight differently from the main body. They glowed faintly blue, while the core maintained a warmer hue. This suggested varying compositions, perhaps layers of material exposed by the breakup. Some parts might have been buried since the dawn of its creation, now revealed for the first time to the universe. These new surfaces carried volatile compounds that evaporated instantly, releasing jets of gas that pushed the pieces subtly toward one another again. It was a form of balance, a self-correcting dance written in physics, but performed with grace. The comet appeared both fragile and unbreakable, falling apart and holding together at once. As data accumulated, a few astronomers speculated that this behavior could hint at a new class of celestial object, something between a comet and a planetoid. The fragment's cohesion could mark the presence of an unknown binding force, perhaps a residual magnetic field frozen from its birth in another star system. If true, it would make Atlas a window into an era before our own sun existed. For the public, the images were mesmerizing. Through high-resolution telescopes, the comet appeared as a cluster of glowing orbs drifting through a cloud of faint dust, like embers suspended in water. To see it was to witness contradiction made visible, destruction that refused to end. By late summer, when the fragments finally began to disperse beyond measurable proximity, they left behind a faint, luminous trail that curved gently toward the edge of the solar system. The instruments recorded one last flare of light before it faded, a final act in a slow performance that no one yet understood. The event left astronomers divided. Some called it coincidence, the random interplay of gravity and gas. Others saw something deeper, a hint that the laws governing matter at cosmic scales may hold subtleties not yet discovered. The comet had defied expectation once again, breaking apart only to remind humanity that even disintegration can be a form of endurance. And in its lingering fragments, drifting now toward the outer dark, there was a message written in silence, that the universe does not waste what it breaks. When the first detailed thermal maps of 3IATLAS reached the analysts, they carried an echo of contradiction. The jets of vapor that should have burst outward from the sunlit surface appeared to move in the wrong directions. Instead of streaming away from the sun, some of them curved back, defying the geometry of heat and shadow. The images came from a network of instruments spread across 3 continents, each confirming the same strange pattern. Plumes of dust and gas erupted sideways, or even toward the dark hemisphere, as if pulled by an unseen hand. The jets were faint but persistent, altering the comet's spin in subtle ways. No known model could reproduce the behavior. At first, the team suspected interference. Perhaps a misalignment in calibration had created the illusion of reverse jets. Yet the corrections brought no relief. The motion was real. The object was venting material against the gradient of sunlight, a gesture that contradicted both intuition and physics. In quiet rooms filled with screens, the researchers replayed the sequence of images again and again. The comet rotated slowly, releasing arcs of dust like the breaths of a sleeping giant, but each exhalation seemed to choose its own path, guided by a logic that no computer could mimic. Some theorized that internal cavities might be channeling gas through labyrinthine tunnels, redirecting the flow. Others imagined surface fractures shaped by magnetism, forcing jets to twist like ribbons of plasma. At the University of Cambridge, a small group began constructing physical models in vacuum chambers, using artificial ice mixed with metallic dust. Under intense light, their samples cracked and emitted vapor along unpredictable paths. The experiment hinted at an answer. If metallic inclusions formed within the ice, they could conduct electricity and heat unevenly, creating local pressure that redirected the outflow. It was a promising theory, but 3IATLAS still refused to fit entirely within its bounds. The comet's rotation made the mystery deeper. Instruments detected irregular changes in its spin rate, small accelerations that followed no discernible rhythm. One moment the rotation slowed, the next it quickened, as though responding to impulses from within. Astronomers measured these changes carefully, mapping them against the timing of each jet. No clear correlation appeared. The movement seemed spontaneous, governed by internal mechanisms no one could name. In a late-night conference call, one researcher compared the behavior to heartbeat irregularities, describing the comet as a system that oscillated between control and chaos. The idea struck a chord. Others began to see it as a kind of self-regulating body, maintaining equilibrium through unpredictable bursts. It was not alive, but it acted alive. The unexpected directions of its plumes also suggested a strange kind of awareness, not intelligence, but sensitivity. Perhaps the comet was responding not to light directly, but to the surrounding environment, feeling the solar wind as a pressure field and adjusting accordingly. If this were true, then its apparent disobedience might actually be adaptation, the remnant instinct of matter shaped by the conditions of another star. In Zurich, a physicist attempted to model this idea mathematically. He treated the comet not as a passive object, but as an active system, interacting dynamically with charged particles. His equations produced elegant spirals, paths of motion that mirrored what the telescopes observed. The curves were beautiful, but incomplete. They explained direction, not cause. Somewhere, a deeper mechanism was missing. For the scientific community, Atlas had become a paradox that invited poetry. Some called it a ghost engine, a relic of motion from a time before the solar system existed. Others likened it to a musician playing an instrument of vapor, its jets forming melodies in the vacuum. Yet even behind the metaphors, the data remained stubbornly literal. Something was pushing the comet from the inside, a process that broke the neat divide between physics and imagination. When the Hubble Space Telescope recorded a long exposure during one of these emissions, the image captured thin filaments of dust that curled like smoke in slow motion. Their motion traced complex arcs, spiraling back toward the nucleus before dispersing into the void. It looked less like an explosion and more like choreography. Public fascination followed quickly. News outlets described the comet as dancing against the Sunday. Artists rendered its motions in swirling trails of light, while scientists remained cautious, bound to the numbers. Yet even they could not escape the sense that something extraordinary was unfolding, a glimpse into behaviors that might rewrite how we understand sublimation and internal dynamics in cosmic bodies. By autumn, the comet had rotated thousands of times, each spin accompanied by small, asymmetric releases. The result was an unpredictable journey through the solar wind. Its path shifted ever so slightly, creating tiny deviations that accumulated over weeks. When plotted, these changes resembled waves, patterns that seemed to ripple across its orbit, like the imprint of thought. No one called it consciousness, but many felt an unease that language could not hide. Matter, it seemed, was capable of complexity beyond expectation. The jets of 3IATLAS were not mere byproducts of heat. They were expressions of structure, memory, and motion fused into one phenomenon. As it continued to drift, the comet left behind a faint, curving ribbon of dust. Each turn of that ribbon marked another event, another instance of rebellion against simple physics. And somewhere within that silent ballet of vapor and light, a truth waited to be understood, that even the smallest fragment of the universe can act as though it remembers how to move. The deeper the scientists peered into the enigma of 3IATLAS, the more they began to suspect that gravity itself might not be telling the whole story. For centuries, the cosmos had appeared to dance to the same quiet rhythm, each object tethered to every other by the invisible pull that Einstein and Newton had both described in their own languages. Yet here was something that did not seem to care. Its path, its acceleration, its spin, all hinted that some other principle might be whispering beneath the familiar song of attraction. At the European Organization for Astronomical Research, physicists revisited equations that had not been touched in decades. They examined the curvature of space around the comet and the influence of solar tides upon its course. The numbers agreed with the known constants, yet the observations defied them. The object's trajectory carried a subtle grace, as though it moved through a region of softened gravity. No one could find the source of the effect. Some began to wonder if what they were seeing might be a manifestation of quantum forces at macroscopic scales, an echo of phenomena that usually vanish inside atoms. The idea was radical but not impossible. Quantum fields pervade everything, and in rare situations they can interact with matter in ways that shift its apparent weight. Could Atlas be wrapped in such a field, drifting along a quantum current rather than following the predictable arc of the sun's influence? At Princeton, a theorist proposed that the comet might be moving through a pocket of distorted spacetime, a temporary bubble created by the interplay of interstellar matter and magnetic fields. In this scenario, gravity would not be weaker, but differently shaped, guiding the comet through a landscape invisible to normal instruments. The notion blurred the boundary between astrophysics and speculation, yet it held the power to explain what had otherwise become inexplicable. Elsewhere, at the University of Copenhagen, researchers turned to dark matter simulations. The galaxy is filled with unseen mass that exerts influence through gravity alone. Perhaps the comet had passed through a thread of this hidden material, receiving a minute gravitational nudge that altered its orbit. When they plotted the possible locations of dark matter filaments intersecting the solar system, one faint strand came surprisingly close to the comet's path. If true, it would mean that the same cosmic fabric that shapes galaxies might also tug at a single piece of interstellar dust. While the theoreticians debated, the observers continued to gather data. Laser ranging, photometry, and spectroscopic tracking all agreed on one thing: the deviations were real. The comet was not obeying the pure geometry of the solar field. Each time its position was plotted, the difference grew by a fraction of a second in angular measurement, a small but persistent rebellion against precision. For most, this would have been a curiosity, an error to be absorbed into statistical noise. But for those who had dedicated their lives to the study of motion, it was a revelation. The universe had once again shown that certainty is a luxury, not a law. At a symposium in Paris, a physicist described the comet's path using the phrase gravity's illusion. He explained that perhaps what humans call gravity is only a visible layer of a deeper principle, one that connects energy, mass, and space in ways not yet seen. The audience listened in silence. Some nodded in fascination, others in doubt, but all felt the tremor of possibility. Back in the observatories, the telescopes continued to follow Atlas as it receded from the Sunday. Its motion began to settle, the deviations shrinking but never vanishing entirely. It seemed to obey when watched, then drift slightly, once attention turned elsewhere. It was an odd coincidence that no one could quite dismiss. The comet behaved as if aware of being measured, a trick of perception that mocked human faith in objectivity. Physicists have long known that observation changes reality at the smallest scales. In the quantum world, particles alter their states when looked at. To imagine such behavior in a celestial body was madness. Yet here was data that flirted with the idea. Perhaps the act of measuring, of turning human technology toward the object, had disturbed something subtle in the space around it. In an unguarded moment, one researcher wrote in her notes, "It is as if gravity bends to curiosity." The line was not meant for publication, but it captured what many felt. The comet was beginning to act as a mirror for the limitations of science, revealing that the tools built to measure the universe may also distort it. For now, there was no proof of quantum effects or dark matter interference. There were only patterns, inconsistencies, and silence. Yet that silence carried weight. It suggested that the universe might not be a perfect machine after all, but a living fabric capable of subtle improvisation. When 3I/ATLAS finally crossed the orbital distance of Jupiter, its path steadied. The anomalies softened, as if the local rules of reality had reasserted themselves. The sun reclaimed its authority, but in the data logs and mathematical notes, traces of the rebellion remained, quiet reminders that even gravity, the most trusted of cosmic forces, might sometimes be an illusion. The comet continued outward, indifferent to the debates it had ignited. Behind it, the equations settled back into their old rhythms. But something had shifted in the human imagination. The certainty that once surrounded gravity now carried a small crack, and through that crack, wonder began to pour. Whispers began to ripple through the scientific community, soft at first, half joking, half serious. If gravity could not fully explain 3I/ATLAS, then perhaps the comet was not entirely natural. The suggestion was fragile, spoken cautiously in conference corridors or buried in footnotes, but it persisted. Could this visitor be a relic, not of geology, but of intention? The idea had roots in memory. When the first interstellar traveller, Oumuamua, passed through in 2017, a few dared to propose that it might be artificial. It had moved without jets, accelerated as if driven by radiation pressure, and reflected light in a way that hinted at flat, engineered surfaces. The notion had been dismissed as science fiction, yet it never truly died. Now, as Atlas performed its own unaccountable ballet, that earlier speculation found new voice. At the Massachusetts Institute of Technology, a small team of astroengineers decided to treat the comet not as a rock, but as an artifact. They built computer models that imagined it as a fractured structure of unknown design, possibly hollow. When they matched these simulations to the observed motion, the results aligned better than anyone expected. A hollow, reflective body would respond to sunlight with precisely the gentle push seen in the data. Still, even the most daring among them hesitated to call it evidence. The idea of alien technology demanded extraordinary proof, and Atlas offered only fragments. Its irregular jets, its delayed sublimation, its metallic hints in the spectrum, all could be coincidences, natural quirks magnified by human imagination. Yet, coincidence after coincidence begins to resemble pattern. The more the discussion spread, the more uncomfortable it became. At public lectures, speakers carefully avoided the word artificial. In private conversations, however, some confessed that the comet's resilience felt designed. It had survived radiation, heat, and disintegration with a precision that seemed deliberate. One astronomer compared it to a probe built to endure the silence between stars. In a laboratory in Pasadena, a young researcher reconstructed the object's light curve in 3 dimensions. What emerged was an elongated form, not spherical but subtly angular. The shape bore faint symmetry, edges that repeated at almost regular intervals. The mind seeks design wherever it finds repetition, and this pattern tempted that instinct. But geometry in space can deceive. Rotation and perspective can create illusions of order. The debate continued. Outside the realm of numbers, the idea took hold in culture. Headlines spoke of a mysterious messenger. Documentaries whispered about cosmic relics. Artists painted visions of ancient crafts adrift among nebulae. The scientific community, cautious and methodical, watched with a mixture of irritation and awe. For them, 3I/ATLAS was still a body of ice and dust, but the possibility that it might once have been something more pressed gently on the edges of reason. Some theorists proposed a middle path. Perhaps the object was not built, but shaped by physics that mimic design. The forces of rotation, magnetism, and sublimation could carve matter into geometric harmony over time. What appears intentional might be the natural outcome of cosmic patience. The universe, after all, has sculpted beauty long before intelligence learned to see it. Others explored the stranger alternative. What if intelligence had indeed played a role, not as builder, but as influence? Could a civilization, long extinct, have engineered fragments of their world to drift forever, carrying trace signals through interstellar dark? The thought was poetic more than probable, yet it refused to vanish. To test for artificial signals, radio arrays across the globe turned toward the fading comet. The SETI network joined briefly, scanning its vicinity for any sign of narrowband emission. For weeks they listened, mapping frequencies across the spectrum. The silence that followed was complete. No modulation, no rhythm, no message. Just the steady hum of background noise, older than galaxies. Yet silence can also speak. To some, the absence of a signal made the mystery deeper. Perhaps, they said, whatever intelligence once touched this object had no need for communication. Perhaps it was not meant for us at all. In Switzerland, a philosopher of science wrote that the fascination with artificiality revealed more about humanity than about the comet. He argued that when confronted with mystery, the human mind instinctively searches for mirrors of itself. The suggestion that 3IATLAS might be built, he said, is simply our longing for company turned into mathematics. The essay circulated quietly among scientists, its conclusion both humbling and consoling. Even in the vast emptiness, we are always looking for a reflection. As winter came, the comet grew dimmer, receding from the warmth that had awakened it. The debate faded with its light. Official papers returned to neutral language: anomalous brightness, irregular outgassing, unusual structure. But beneath the restraint lay something that could not be erased. The realization that the line between natural and artificial, between accident and intention, might not be as clear as once believed. When the last visible image of 3IATLAS was captured, it showed a faint, symmetrical arc, glowing softly against the stars. The astronomers recorded it without comment, but later, when the data reached the archives, one technician noted a quiet observation in the margin. It looks as if someone wanted it to be seen. The listening began long before dawn. Across quiet deserts and mountain plateaus, the great ears of the planet turned upward, tuned to the same invisible hum. Array dishes that usually map the whisper of galaxies were now listening for something smaller, more personal, a breath of sound from 3IATLAS. The signal they sought was not a human message, not a broadcast of intent, but a murmur that might suggest complexity. The comet had already challenged gravity, chemistry, and light. Now, it tempted curiosity itself. If the universe kept archives of its own memory, perhaps radio waves were the language it used. In the control rooms, engineers watched bands of static scroll across their screens. It was an ocean of noise, each wave a fragment of ancient creation. The frequencies around the comet were clear, steady, and silent. Yet within that silence were faint fluctuations, small rises in amplitude that repeated at irregular intervals. They were too weak to form a pattern, too consistent to ignore. One operator at the Green Bank Observatory described it later as listening to breathing underwater. The sound was neither natural nor artificial, only persistent. She increased the gain, filtered the cosmic background, and heard the same pulse again. The equipment recorded it for hours, then days, until the data filled an entire archive. Across the world, other arrays joined in. From Chile's Atacama Desert to the plains of South Africa, antennas tilted toward the comet's path. Each detected the same rhythm, a slow repetition hidden beneath the static. Some believed it to be an artifact of instrumentation, a trick of interference from solar radiation. Others wondered if the object itself was interacting with electromagnetic fields in ways that produced the illusion of sound. When analysts overlapped the recordings, something uncanny emerged. The pulses, though irregular, aligned at intervals that followed the comet's rotation period. Every time it turned, the rhythm shifted slightly, like an echo adjusting to motion. It was a coincidence too perfect to dismiss. A group of astrophysicists at Berkeley took the recordings and converted the frequencies into audible tones. What they heard was not music, not code, but something resembling a natural vibration, as if the comet were resonating with the fields of space. The sound rose and fell, forming waves that faded into each other like sighs. The researchers played it late at night, half in jest, half in awe. There was no message, no signal repeating in prime numbers, no pattern that could pass as language. But the rhythm had beauty. It evoked the sensation of wind through vast emptiness, of the slow breathing of the cosmos itself. The discovery was published quietly, described as an electromagnetic artifact likely caused by charged dust interacting with the solar wind. Yet, even the authors admitted that the coherence of the pattern remained unexplained. The silence of the comet became part of its identity. It did not shout like a machine or sing like a planet's magnetosphere. It whispered, barely audible, as though speaking in a voice meant for no one. The radio telescopes caught that whisper, amplified it, and played it back to humanity like a ghostly lullaby from the edge of the system. In the weeks that followed, artists transformed the data into soundscapes. Film composers used it as background for pieces about isolation and infinity. To the public, it became known as the Pulse of Atlas. The name spread quickly, appearing in news articles and documentaries, sometimes romanticized, sometimes questioned. Within the scientific community, opinions divided sharply. Some argued the pulse was an illusion born of human pattern seeking. Others insisted it was real, a product of resonance between charged dust and solar particles. A few quieter voices suggested a third possibility, that the comet was not emitting the pulse, but amplifying something already present, a background rhythm that had always been there, unnoticed, until it found the right mirror. One physicist from Japan compared it to wind across the mouth of a cave. The cave itself does not sing, it only shapes the sound that passes through. Maybe Atlas was such a shape, a moving cavity in the fabric of plasma, giving temporary voice to forces that surround every world but remain unheard. When the final transmission ended, the receivers returned to mapping distant galaxies. The static resumed its familiar shape. Yet those who had listened could not forget the rhythm. It lingered, faint as memory, somewhere behind the hum of daily life. Later, when the recordings were cleaned and archived, one engineer marked a final note beside the last waveform, a silence too structured to be empty. The line was neither scientific nor poetic. It was simply honest. For in that measured stillness, something of 3IATLAS seemed alive, not in the way of flesh or thought, but in the quiet persistence of motion that feels like breathing. The more carefully humanity listened, the more it began to realize that the true message of 3IATLAS was not contained in what it said, but in what it refused to say. The comet emitted no language, no broadcast, no trace of design. Its silence was total, and in that silence, the cosmos itself seemed to pause. Radio telescopes fell quiet again, their dishes turning away from the cold coordinates where the object once glimmered. The soundless data still arrived, lines of numbers on endless screens, but they carried only emptiness. There was no rhythm now, no pulse, no whisper. The comet had stopped speaking, if it had ever spoken at all. Scientists expected disappointment, but what settled over them was something stranger. The absence of a signal felt heavier than any discovery. It pressed against the boundaries of understanding, reminding them how small the act of listening really was. For decades, humans had sent their voices into space, expecting to be heard. 3IATLAS reminded them that silence could be an answer. At observatories from Hawaii to the Canary Islands, astronomers stood beneath the night sky, staring at the faint streak that marked the comet's departure. It was slipping away, retreating toward the outer dark, trailing a dim mist that would soon vanish into the black. The silence it left behind became a mirror for the observers themselves. They saw their own reflection in it, the endless desire to find meaning in what might have none. In academic circles, the lack of a signal became a topic of study in itself. Papers were written about the psychology of expectation, about the anthropic bias that drives humanity to see intention where there may be only entropy. Yet even the most rational among them could not fully escape the emotional gravity of the moment. To watch something so foreign and so beautiful vanish without a word felt like witnessing the withdrawal of the universe's attention. A poet working with the European Space Agency described the event in different terms. "We waited for the sky to speak," she wrote, "and it answered with stillness. The line was quoted in scientific journals, not as evidence, but as truth of another kind. The silence also provoked philosophical reflection. What if the void between stars is not empty, but filled with forms of existence that never needed to speak? What if communication, as humans understand it, is not universal but local, a peculiarity of living matter? Perhaps Atlas was not withholding meaning, perhaps it simply had none to share. For some, that realization brought despair. For others, it brought peace. The universe, stripped of dialogue, became a vast cathedral of motion where every orbit and reflection was its own kind of language. The comet, silent and solitary, had become a symbol of that idea. Meanwhile, instruments continued to record. The tail of the comet, once brilliant in reflected sunlight, began to dim as it crossed into the colder regions beyond Mars. Observations grew harder, data scarcer, until finally only the most powerful telescopes could find it. The faint shimmer of dust stretched into nothing, and then even that disappeared. In the absence of new information, imagination filled the gap. Some believed the object had disintegrated completely, its fragments merging with interplanetary dust. Others suggested it might continue its journey intact, coasting into interstellar darkness once more. The truth was unknowable. At a conference in Geneva, a physicist presented the final measurements of the comet's motion. She ended her talk not with numbers, but with a pause so long the audience could hear their own breathing. "It gave us nothing," she said softly, "and that is why it matters." The statement lingered long after she left the stage. It was not defeat she was describing, but reverence. In that stillness, humanity had been confronted with its oldest companion, the unknown. As the months passed, telescopes turned to new targets, new mysteries, new lights to chase. But in the collective memory of science, 3IATLAS remained different. It was not a discovery in the conventional sense. It was a moment of humility, a reminder that silence, too, can carry information. In laboratories and lecture halls, the comet's data continued to circulate. Researchers still searched for patterns in the faint echoes of its passage, but many knew that the search itself had become the story. The object had come and gone, leaving behind only reflection. One winter evening, in an observatory on Mauna Kea, a student stood beside a telescope long after her shift had ended. She watched the stars tremble in the thin air and thought about the comet that had refused to speak. The thought brought her not sadness, but calm. She wrote in her logbook, "Perhaps the universe does not answer because it is still listening." The line was never published, but it carried the quiet truth that every scientist eventually learns. Sometimes silence is not absence. Sometimes it is the sound of the infinite thinking. Patterns began to appear where none were expected. After the silence of radio telescopes and the dimming of light, analysis turned inward to the mathematics of motion itself. Across weeks of archived data, subtle rhythms began to emerge, woven into the spin and orbit of 3IATLAS. The comet did not rotate evenly. Its spin shifted with delicate irregularity, the kind that suggests chaos but hides design. When mapped across time, those fluctuations formed a fractal signature, a geometry that repeated itself on every scale. The curve of its motion resembled natural patterns seen in coastlines, snowflakes, or even neural networks. It was as if the object had become a diagram of complexity, carved not by mind, but by the long patience of the cosmos. Mathematicians at Oxford noticed it first. They applied chaos theory to the trajectory data and found harmonics that mirrored self-organizing systems. The numbers oscillated between order and randomness, never settling. To some, it was a simple reflection of physics. To others, it hinted at something deeper, the same pattern that life itself follows. The comet's rotation seemed to encode balance within instability. Each irregular movement corrected the one before, maintaining equilibrium without repetition. Such behavior can occur in nature, yet rarely with this precision. One researcher compared it to the way heartbeats vary in a healthy organism, never perfectly regular, yet sustained by subtle feedback. As these findings circulated, they began to alter the tone of the conversation. The language shifted from technical to contemplative. No one was claiming the comet was conscious. yet it behaved as though guided by memory. The interplay of motion and resistance suggested response, not randomness. Even skeptics found themselves describing it with verbs usually reserved for living things: adjusting, adapting, breathing. Physicists at Caltech sought a physical mechanism behind the patterns. They proposed that asymmetrical jets of vapor might create feedback loops, each release of gas altering the rotation enough to influence the next. Over time, the process could evolve into a self-stabilizing rhythm. Their simulations produced results that matched observation almost perfectly. Still, the explanation did not diminish the wonder. A natural algorithm had emerged from ice and light, a quiet intelligence born of physics alone. In a late-night meeting, one researcher remarked that the comet seemed to echo the behavior of ecosystems on Earth. Every jet, every rotation, every flicker of light contributed to a larger equilibrium. Nothing wasted, nothing fixed. "It learns," she said softly, though she meant it only metaphorically. The room fell silent, the words heavier than they should have been. Meanwhile, mathematicians pursued the geometry further. The comet's trajectory through the solar system displayed resonance with planetary positions, forming shapes reminiscent of ancient orbital harmonics. Each intersection of paths could be drawn as a pattern of nested spirals. The resulting map looked less like a diagram of motion and more like a work of art. When visualized, these spirals carried a haunting beauty. They suggested a harmony between chaos and symmetry that no human composer could have written. It reminded some scientists of music, the kind not played but implied, a melody built into the mechanics of existence. Philosophers of science began to write about it. They described the comet as a demonstration of how nature encodes meaning without language, how mathematics becomes poetry when viewed through the right lens. In those essays, 3IATLAS was no longer a frozen rock, but a moving metaphor for balance in a turbulent universe. One physicist, known for her skepticism, surprised her colleagues by calling the comet a mirror of thought. "If consciousness is the ability to maintain coherence in change," she said, "then this object thinks, at least in the language of motion." It was not a literal claim, but the sentiment spread quickly. The idea that non-living matter could exhibit the logic of life felt both thrilling and humbling. Artists, too, found inspiration. Painters and composers began to translate the data into visual and auditory forms. The variations in spin became brushstrokes, the orbital harmonics became notes. Galleries filled with slow, meditative works depicting spirals of dust suspended in deep space. Listeners described the resulting music as both mechanical and emotional, the sound of equations dreaming. By the time winter returned to the northern hemisphere, the fascination had turned inward once more. The comet, now barely visible even through the largest telescopes, continued to haunt human imagination. It had become a symbol of coherence in chaos, of intelligence hidden in pattern. In universities and observatories, the data remained on screens long after the comet had gone. Researchers stared at the spirals, tracing the motion again and again, each time finding something new. The geometry seemed endless, like a thought repeating itself without ever arriving at an answer. Late one night, a mathematician wrote a single line at the bottom of a paper she would never publish. Perhaps everything that moves remembers how it began. It was speculation wrapped in poetry, yet it captured the quiet truth that 3IATLAS had revealed. In its spiraling path, the comet carried not a message, not intelligence, but a reflection of how the universe learns to balance its own disorder. In the end, that was enough. The beauty was not in what the object was, but in what it taught, that even chaos, under the right conditions, can learn the art of harmony. From the residue of earlier data, a quiet revelation began to form. The trail that 3IATLAS left behind was not made only of dust and gas. It shimmered faintly in wavelengths no instrument had been designed to notice. When the first enhanced images were processed, the trail appeared to twist in unexpected ways, curling against the solar wind as if it possessed a faint intelligence of its own. Microscopic examination of the captured particles revealed surprises even deeper. Each grain carried a structure more intricate than snowflakes and more deliberate than chaos. They were not smooth, nor rough, but patterned with tiny ridges that seemed to fold upon themselves, forming shapes that repeated at several scales. To the researchers, it felt as though geometry itself had taken a new direction, exploring possibilities unimagined in earthly laboratories. A team at the National Optical Observatory developed a new form of scattering analysis to study the light reflected from these particles. The results unsettled even the most experienced among them. The dust behaved as if woven from materials with different refractive indexes, alternating between transparency and opacity within fractions of a micron. It was like looking at frozen interference patterns, light made solid. When the same particles were placed under a vacuum microscope, they reacted strangely to small changes in temperature. Instead of sublimating, they rearranged, bending, and locking into new crystalline forms. The transformation was reversible, almost like breathing. Heat in, expansion, cold in, contraction, each cycle perfectly measured, never destructive. One physicist described it as a material that had learned patience. Theoretical chemists tried to simulate the process using quantum modeling. No known compound reproduced the effect. It required the coexistence of elements rarely found together, traces of nickel, silicate dust, and complex carbon rings in ratios that defied probability. Some suggested that interstellar radiation over billions of years could have reorganized the molecules into metastable networks. Others whispered that the grains might be fragments of matter born in the shockwaves of stellar death, a mixture forged where planets once dissolved. The conversation moved from laboratories to think tanks, from analysis to speculation. Could the composition of these grains represent a transitional state between solid and plasma, a kind of semi-living material? The notion was radical, but the evidence hinted at self-organization. When exposed to magnetic fields, the dust aligned into filaments, tracing delicate webs that pulsed with faint electric charges. In a dimly lit room at a European research centre, a scientist watched the display as the particles danced under the influence of magnetism. They gathered, divided, and rejoined, never colliding. "It listens," she murmured, meaning only that the material responded, but the phrase lingered. It was as if the dust understood the field around it. Further tests showed that the grains emitted tiny bursts of photons when disturbed. The light they produced was faint, almost biological, like the glow of deep-sea organisms reacting to motion. Some began calling it quantum phosphorescence. Others, less formal, nicknamed it the comet's heartbeat. The data suggested that the comet's debris might be a bridge between the inert and the dynamic, a form of matter caught between the stillness of rock and the adaptability of life. If confirmed, it would imply that interstellar space is capable of shaping complexity without the need for biology, that evolution could occur even among particles and fields. One research paper proposed that these grains could serve as templates for molecular assembly in young planetary systems, seeding future worlds with the potential for organic chemistry. In this view, 3IATLAS was not merely a traveller, but a courier of possibility, carrying the architecture of creation between stars. The idea spread quickly through journals and documentaries. For a brief moment, scientists and artists spoke the same language again. The comet became a metaphor for continuity, for the way matter remembers form long after its origins have vanished. By the time the dust samples had been catalogued and archived, new mysteries had already begun to bloom. Some of the particles, stored under controlled conditions, continued to shift imperceptibly over months, as though still responding to invisible forces. The instruments detected faint electromagnetic signatures that pulsed without cause. Nothing alive could be that slow, and nothing dead could move at all. One evening, a senior researcher stood before the containment unit, watching the faint shimmer of particles drifting in suspension. She found herself speaking quietly into the glass. "You came from a place we'll never see," she said. The words were not meant for anyone, yet they seemed appropriate. The grains moved slightly, a coincidence that felt like an answer. In that still laboratory, surrounded by silence and the soft hum of machines, the realization took root. The universe might not distinguish between life and matter, between purpose and chance. Perhaps every atom carries the memory of its journey, waiting for the right light to remember its shape. And somewhere beyond the orbit of Mars, 3I, Atlas, continued its slow retreat into darkness, leaving behind its dust an archive of form, a whisper of what matter can become when time decides to experiment. Long after the dust had settled in collectors and the light of 3I, Atlas had faded from telescopes, the question of origin began to stir again. To understand where such material could have been born, scientists looked outward, past the familiar spiral of the Milky Way, into the deep structure of the galaxy itself. They searched for a birthplace that could produce chemistry so alien, yet so delicately balanced. The isotopic signatures in the comet's residue carried clues that pointed toward an old region of space, a sector filled with faint red stars and the remnants of stellar collapse. It was a part of the galaxy shaped by death rather than creation, a graveyard of suns whose explosions had seeded the void with heavy elements. Every ratio in the data hinted at such ancestry. The grains bore iron enriched by supernovae, carbon from long-dead giants, and trace elements formed under extreme pressure. One astronomer described it as the genealogy of extinction. The comet was a child of broken worlds. Its body was forged from fragments of ancient stars that had burned too quickly and died too young. What now drifted through the solar system was not a messenger from life, but from aftermath. Through computer simulations, researchers recreated the likely sequence of events. A cluster of stars once existed in the far reaches of the Orion Arm, orbiting a dense molecular cloud. Within that cluster, one of the larger stars exploded, scattering debris across light years. Among the wreckage, gravity gathered dust and ice into small bodies. Frozen memorials of what had been 3IATLAS may have been one of them, formed from ashes and then ejected when its home system was torn apart. For billions of years it wandered through the interstellar dark, passing through clouds of charged gas and regions bathed in radiation. Each encounter altered it slightly, layering new chemistry upon old. Over time, the object became a record of cosmic weather, its surface etched with the memory of collisions too small to see, but too numerous to count. The idea that such an object could survive the chaos of space for so long fascinated researchers. The universe, they realized, preserves its own fossils, not bones or shells, but patterns of matter frozen in perpetual motion. Each comet, each fragment, is a survivor of events that would annihilate entire worlds. At the Institute for Cosmic Origins, a group of astrophysicists examined the energy profile of the comet's orbit. The numbers suggested that it had once been part of a binary star system, perhaps drawn into resonance with a dying companion. When that companion collapsed into a white dwarf, gravitational waves may have thrown smaller bodies into interstellar escape trajectories. 3I, Atlas could have been born in that violence, carrying within it the memory of two suns locked in farewell. The theory fit the data perfectly, but it also carried a strange melancholy. To think that this glowing wanderer had been cast out by the death of its home made its journey through our system feel less like coincidence and more like destiny. It had travelled not to tell a story, but to remember one. As more evidence accumulated, chemists and physicists found themselves working side by side with cosmologists. They traced the isotopic fingerprints of the dust until they arrived at an age between 8 and 10 billion years. That would make the material twice as old as Earth, perhaps older than the Sun itself. The comet, then, was not merely alien in origin, it was ancestral. One scientist remarked quietly that 3I, Atlas, might be older than the concept of planets. It had drifted through epochs when galaxies were still colliding, when the first metals were forming from primordial hydrogen. In its core lay the story of the universe, learning to make complexity. The study of such ancient matter forced a reconsideration of time. When objects carry histories older than their observers, time becomes circular, not linear. The comet that entered human instruments in this century was the same one that watched the first stars ignite. Its motion linked past and present in a single, unbroken gesture. A poet working with the research team called it the interstellar genealogy, a lineage traced not by blood but by radiation. Each atom in the comet's structure had been part of another world, another star, another catastrophe. Even in its silence, it carried continuity. The comet's age also offered perspective. If something so fragile could survive the chaos of galaxies, then permanence was not an illusion, but a possibility. The same physics that destroy also preserve. The same gravity that breaks apart systems can carry their fragments safely across eternity. When the scientists presented their findings, they spoke with an unusual mixture of precision and wonder. The equations were elegant, the conclusions sound, yet beneath the data lay a quiet awe. They had glimpsed not the beginning of a mystery, but its origin in time. That night, as the presentation ended, the lead researcher stepped outside the observatory and looked up at the same sky that had once sheltered 3IATLAS. Above her, the Milky Way stretched like a wound, stitched with light. She realized that the comet's journey was not one of intrusion, but of return. It had come home to the galaxy that made it, circling once more through the light of its distant kin. The thought was simple but profound. The universe remembers, not through words, not through design, but through motion that never ceases. Every orbit is a memory, every fragment a continuation. 3IATLAS was proof that even after death, matter keeps moving toward reunion. From the patterns of origin emerged a more haunting idea, that 3IATLAS might not be a lone wanderer at all, but a remnant of collision, a scar travelling through the dark. Every element of its chemistry hinted at trauma. Ratios of isotopes, fractures in its mineral composition, and microscopic fissures within its dust, all pointed to a violent past. It was as if the object had been born from an event that tore a world apart. In a quiet lab in Munich, an astrophysicist ran simulations of what could produce such signatures. The model showed a planet orbiting too close to its star, drawn inward by gravity until its crust ruptured under tidal stress. Mountains would have collapsed, oceans would have turned to vapor, and fragments would have been flung into space. Some of those fragments, cooled by distance, could have condensed into frozen bodies like comets. Over time, their trajectories would carry them beyond their home system and into the interstellar deep. If that scenario were true, then 3IATLAS was a survivor of catastrophe, a shard of a world erased. The thought transformed the comet from curiosity into elegy. Every particle of ice and dust became a relic of a place that no longer existed. Astronomers studying the comet's structure noticed that the reflective properties of its surface were not uniform. Some regions scattered light, as if made of glass, others absorbed it like volcanic ash. The difference suggested a violent process of formation, a collision or explosion that mixed molten and frozen materials before they could separate. This dual nature made Atlas both bright and dark, a contradiction visible even through a telescope's eye. Geochemists examined the mineral ratios and found traces of silicates, normally formed under immense pressure, far higher than what small comets experience. Such minerals belong to planetary mantles, not icy wanderers. It was further proof that this object had once been part of something far larger. The possibility stirred quiet reverence among the researchers. To touch the dust of Atlas was to handle the ashes of a lost world. One scientist kept a sample sealed in glass on her desk, not for study but as reminder. She said it helped her imagine how fragile creation can be. At the European Southern Observatory, the team ran high-resolution thermal imaging of the comet's surface. They discovered subtle variations in heat emission, small areas that cooled slower than others. These regions corresponded with patches of metallic content, suggesting remnants of a planetary core. If correct, it would mean Atlas carried within it the ghost of a world's heart, still radiating the faint memory of its birth. Such evidence drew together physics and imagination. A planet once thrived somewhere in the galaxy, perhaps with moons, perhaps with storms and seasons. Then, through the indifferent mechanics of gravity, it was destroyed. From its debris, a single fragment endured long enough to reach the sun and briefly cross paths with humankind. At conferences, the term collision hypothesis became shorthand for this origin story. Some resisted it, arguing that the data could still describe a natural aggregation of interstellar material, but most agreed that the evidence leaned toward violence. The universe, after all, creates through destruction. New systems are born from the ruins of old ones. Philosophers found symbolism in that idea. They wrote that the comet embodied the persistence of form through ruin, that it was the voice of entropy speaking softly of memory. In their essays, Atlas was not a messenger, but a mourner, carrying the dust of a forgotten sun across eternity. Theorists also considered what this might mean for planetary evolution. If fragments like Atlas can escape their doomed systems, then every collision in the galaxy becomes an act of distribution. The chemistry of one star can seed another. The atoms in this comet might someday fall into a forming world, giving rise to new compounds, perhaps even life. In this way, destruction becomes a kind of generosity, spreading possibility through the void. An astrophysicist from Chile described it simply: it is the galaxy's way of recycling memory. The phrase caught on, appearing in scientific journals and documentaries alike. It captured the paradox that defined the object, born from ruin, yet carrying renewal. When artists heard the story, they reimagined the comet as a fragment of a drowned civilization, a silent ark bearing the last remnants of a world's atmosphere. Paintings and films began to appear, showing cities frozen in ice drifting among the stars. Though the science never claimed such drama, the imagery resonated with something human. The idea of survival, even in fragments, has always moved the imagination. Late one evening, a researcher studying the comet's spectral data paused his work and looked out through the observatory dome. He thought about that lost world, whatever it had been, and felt an unfamiliar kinship. "Perhaps we are all debris," he said to no one. "Perhaps every planet is a brief arrangement of dust before becoming a traveller." The thought lingered like static. Outside, the stars were quiet, their light arriving from ages older than grief. Somewhere beyond them, more fragments like Atlas must still be drifting, carrying the ruins of their origins toward other suns. The collision that destroyed its home had ended an age, but begun a journey. Each orbit since had been a repetition of that first explosion, slowed to the scale of time itself. What humanity saw as a comet was the universe remembering impact. What it left behind was not a warning, but a promise, that even from ruin, motion continues, and motion is its own form of survival. Light, magnetism, and motion began to intertwine in ways that no one could have predicted. When the instruments turned again toward the path of 3IATLAS, they recorded something new, a faint signature, neither light nor heat, moving like a pulse through the void. The data arrived in waves, rising and falling with intervals that hinted at intention but spoke only of rhythm. The signature was magnetic, a whisper in the field that surrounded the comet. It appeared as a slow oscillation, a dance of charged particles that drifted out from the nucleus and curved through space. At first it seemed a measurement error, a trick of overlapping frequencies. But as the recordings accumulated, the pattern deepened. The oscillations were too structured, too deliberate to be noise. At the Center for Space Plasma Physics in Stockholm, scientists began to reconstruct the signal. What emerged looked less like turbulence and more like a breathing field. The strength of the magnetism rose gently, peaked, then receded, repeating in a cycle that matched the comet's rotation. Each time Atlas turned, the field folded in upon itself, releasing faint harmonics detectable across millions of kilometers. Some thought it was solar wind trapped in a magnetic sheath, a natural resonance caused by the interaction of charged dust with plasma. Others wondered whether the field was intrinsic, a remnant of its formation near a star dense enough to forge magnetic minerals at birth. The possibilities branched into conjecture, but one fact held firm. 3I. Atlas carried a magnetism unlike any other comet on record. When plotted in colour, the field resembled a luminous shell rippling outward in pulses. To the eye, it looked alive, as if the object were wrapped in invisible wings. No telescope had ever captured such structure before. The discovery unsettled everyone who saw the image. It was not supposed to exist. Physicists began exploring the implications. A magnetic field strong enough to sustain itself without a planetary core suggested unknown processes at work. Perhaps the material of the comet had entered a superconductive state under extreme cold, allowing currents to circulate indefinitely. Or perhaps interstellar travel through ionized gas had polarized its composition, turning it into a vessel of trapped magnetism. If the latter were true, the comet was more than a traveler. It was a container, carrying the remnants of cosmic fields across time. The same magnetism that shaped stars could be preserved inside its frozen heart, waiting for a moment of heat to wake it. In a lab in Canada, a researcher built a miniature model to test this idea. She coated iron-rich dust with layers of organic carbon and exposed it to extreme cold. When she introduced weak currents, the structure retained magnetism long after the power was removed. It was a crude echo of what might occur inside Atlas. "It remembers," she said softly to her assistant. The phrase, once again, escaped the bounds of metaphor. The field around the comet also affected its surroundings. Spacecraft sensors recorded slight variations in charged particle flow when crossing its projected path. The solar wind bent slightly, forming an eddy that persisted long after the comet had passed. It was as though Atlas left behind a magnetic footprint, a temporary alteration in the space it moved through. This discovery reignited discussion about the interaction between magnetism and memory. Some speculated that the field could act as a recording device, capturing fluctuations in plasma as patterns within its currents. If so, 3IATLAS might be carrying a faint record of its own journey, written not in light or sound, but in electromagnetic structure. The hypothesis fascinated both scientists and artists. Musicians translated the field data into sound, transforming each oscillation into tone. What emerged was not melody, but vibration, a deep and trembling hum that seemed to resonate in the body rather than the ear. Listeners described the experience as standing inside the heartbeat of the cosmos. In the academic world, skepticism remained, but curiosity grew. If magnetic fields could store echoes of the environments they passed through, then every object in space might carry history folded into its shape. Rocks, dust, comets, even planets could act as archives of invisible energy. The idea felt both impossible and true. One paper described the comet's magnetism as the ghost of a vanished sun. The phrase captured the imagination of everyone who read it. It suggested that what appeared as a small frozen wanderer might in fact be the last remnant of a stellar furnace, the cooled memory of a once-living star carried across eons. In the end, the data offered no certainty. The field faded as the comet receded, leaving behind unanswered questions and a single enduring image, a fragment of ice moving through the void, surrounded by a pulse of invisible energy that shimmered like breath. Those who studied it spoke of awe rather than understanding. They knew that whatever its origin, the magnetism of 3I, Atlas had revealed something profound. The universe does not forget the forces that shape it. They linger, invisible but unbroken, waiting in the silence of space to be discovered again. From magnetism, the discussion drifted naturally toward energy itself, the silent engine that animates everything. The question became simple yet vast. What truly moves 3I, Atlas? What source keeps altering its course when gravity alone cannot? As the object retreated into the dim regions beyond Mars, measurements began to show faint accelerations that matched no external influence. The anomaly reappeared, this time deeper and more consistent. The comet did not speed up or slow down in bursts, as it had near the Sunday. Instead, its velocity undulated with a steady rhythm, as if it were being carried by invisible currents flowing through interplanetary space. Analysts ran the calculations again and again, searching for errors. None appeared. The movement was real. Astrophysicists at the Institute for Fundamental Cosmology proposed a hypothesis that felt more like philosophy than mechanics. They suggested that Atlas might be reacting to variations in the vacuum itself. The universe is not truly empty. It seethes with quantum fields, oceans of energy flickering in and out of existence. If the comet's composition allowed it to couple with those fields, then perhaps it was surfing fluctuations of space-time rather than drifting through them. The idea was intoxicating. It hinted that the object was a bridge between ordinary matter and the underlying sea of potential that physics calls the vacuum. To prove such a thing would change the definition of motion itself. For weeks, Debates stretched across time zones. Some called it wishful thinking. Others quietly began designing experiments. At CERN, theorists modeled the effect using virtual particles. They treated the comet as a probe moving through quantum foam. Under certain conditions, fluctuations could create tiny but cumulative thrusts. These would be imperceptible for planets, but measurable in smaller bodies like comets. The model fit the data almost perfectly, yet the conclusion demanded a leap few were willing to take, that the vacuum is not passive but active, capable of imparting momentum. Other teams looked elsewhere for answers. Some explored the possibility of dark energy interacting with matter at small scales. Dark energy is usually associated with the expansion of the universe, but perhaps it manifests locally as pressure or drag. If so, Atlas might be the first object to reveal it. One physicist described the idea as listening to the whisper of creation still echoing through the void. Meanwhile, engineers studied the sunlight itself. Could the radiation pressure be fluctuating in ways we do not yet understand? Solar output is not constant. It pulses with the cycles of magnetic storms and plasma waves. A fragment as sensitive as Atlas might respond to those rhythms, moving in time with the heartbeat of the Sunday. The metaphor was poetic, but the data lent it credibility. Throughout these discussions, the comet became more than an object. It was a question embodied in motion. Every model brought insight, but also contradiction. The more precise the measurements grew, the more they resembled mysteries. In a quiet laboratory in Tokyo, a young researcher plotted the changes in acceleration against cosmic background radiation. To her surprise, she found a faint correlation. The tiny fluctuations in the microwave afterglow of the Big Bang matched the deviations in the comet's motion. It was as if the object were responding to the oldest signal in existence, aligning itself with the faint hum that has filled space since the beginning of time. The result was published carefully, with cautious language and no sweeping claims. Yet, it caught the attention of theorists around the world. If confirmed, it would mean that matter, even now, still feels the residue of its birth. The same vibration that began the cosmos might still ripple through everything, guiding even a comet's slow path through the dark. In the months that followed, the idea expanded beyond science. Writers and philosophers spoke of Atlas as a tuning fork for the universe, vibrating in harmony with the memory of creation. Artists imagined it as a drifting instrument that resonated with the cosmic background, translating silence into motion. One evening, in a lecture hall filled with students, a physicist closed her talk with an image that silenced the room. She said that perhaps Atlas moves because it cannot help but answer the rhythm of the universe that made it. Like dust stirred by breath, it responds to the unseen energy that surrounds everything. Her words lingered long after the slides disappeared. They left behind a quiet recognition that science and poetry had briefly met. The object's journey, so ordinary in its scale, had become a mirror of existence itself. Everything moves, not because it chooses to, but because energy never truly rests. When the data finally stabilized, the numbers showed that the acceleration had diminished. The comet was settling into the outer reaches, the rhythm fading into silence. Yet, even as it grew fainter, the question remained, glowing quietly behind the mathematics. What if every motion is a memory of the first? In that possibility lay the final gift of 3IATLAS, a reminder that every particle, every fragment, is still listening to the beginning, still moving to the same primordial rhythm that once set the stars in motion. Beyond the orbit of Jupiter, the light of 3IATLAS grew faint. Yet the instruments continued to follow it, patient as tides. What they recorded was unlike anything expected. The faintest reflections from its surface carried spectral lines, shifted toward frequencies seen only in the earliest galaxies. For a moment, it was as if the comet were glowing with the memory of the universe's youth. Astronomers had seen relic radiation before, the background echo of the Big Bang that fills the cosmos like a dim and endless whisper. But this was different. The reflected light of Atlas seemed to preserve information about a state of matter older than the stars themselves. It was not the signature of atoms as they exist today, but of something more primitive, an arrangement of energy that belonged to the first few minutes after time began. At Harvard, a group of cosmologists re-examined the data in disbelief. They compared the spectral lines to simulations of baryonic matter from the earliest epochs. The match was uncanny. The ratios of hydrogen to deuterium, the subtle distortions in the frequency of emission, all mirrored conditions known only from theoretical models. Somehow, this small traveller carried the chemistry of the beginning. No one could say how such a thing was possible. Perhaps the comet had formed in a region of space that had remained untouched since the birth of galaxies, a pocket of preserved conditions hidden from entropy. Or perhaps its composition was simply ancient enough to retain the cosmic fingerprints of that time. Either way, the discovery implied that Atlas was not just a relic of another star system, but a relic of the universe itself. As the implications sank in, the comet began to take on new meaning. It was no longer seen merely as a visitor, but as an artifact of time. Within its fragile shell was the same kind of matter that once filled the entire cosmos. To study it was to look backward across billions of years, to see the universe as it had been before gravity sculpted form and light into galaxies. Theorists struggled to describe what they were seeing. One physicist called it a mirror of the early universe, not because it reflected light, but because it seemed to remember the state of everything that came before. It was as if the comet had somehow refused to evolve, preserving a snapshot of primordial order inside its cold heart. Observatories across the world joined the effort to analyze the faint glow. Every measurement seemed to confirm the impossible. Even the polarization of its reflected light bore traces of early magnetic alignment, the kind thought to have vanished billions of years ago. It was as though Atlas had been frozen in the first breath of the cosmos and carried that stillness with it wherever it went. In the quiet of their offices, scientists began to talk less about discovery and more about reverence. They were no longer uncovering facts, but touching something sacred in its endurance. The object had outlasted the stars that might have birthed it. It had seen epochs of light and silence, collision and expansion, and through it all, it had remained whole. At NASA's Goddard Center, a senior researcher gave a lecture to a room full of exhausted colleagues. He spoke not of equations, but of perspective. "We measure it," he said, "but what we are really seeing is ourselves, mirrored in its patience. This comet is not moving through time. Time is moving around it." His words hung in the air like an echo, neither provable nor dismissible. Many who heard them would later say that they changed the way they looked at the universe. For if time can be preserved, even in a fragment of ice, then perhaps eternity is not an abstraction, but a material property hidden inside the smallest of things. The data from the James Webb Telescope added yet another layer to the mystery. Its infrared sensors detected faint absorption lines that should not exist at such temperatures. These were traces of matter in states that belong to the young universe, when densities and energies were far beyond anything now found in nature. The comet, it seemed, was a relic not of a star, but of creation itself. When the results were released, philosophers of science joined the conversation once more. They argued that 3IATLAS blurred the boundary between past and present, that it proved the universe is not a linear story but a looping memory, where fragments of the beginning still wander among their descendants. Outside the observatories, the public followed the story with growing fascination. To many, the comet had become a symbol of continuity, a visible link between what once was and what still is. Children learned its name in classrooms. Writers described it as a frozen echo, a tangible proof that nothing truly disappears. Yet within the scientific community, humility replaced celebration. The object had refused to yield full understanding. Every time a model approached clarity, new data reopened uncertainty. It reminded humanity that some truths are not meant to be solved but simply witnessed. And so the measurements continued, each photon a message from an earlier universe, each reflection a glimpse of what once pulsed in the cosmic womb. 3I. Atlas drifted farther from the sun, its glow dimming, but its meaning expanding. In the stillness of the dark, where time loses its direction, it remained a fragment of the first dawn, carrying within it the silence of beginnings, and showing that the universe still remembers how to be young. beneath the shimmer of fading data, a new kind of clarity took shape. The comet was moving beyond the reach of ordinary instruments, yet technology refused to let it vanish. Humanity began to rebuild its vision, crafting eyes capable of seeing what ordinary optics could not. In laboratories spread across continents, engineers shaped mirrors from alloys thin as frost. Quantum detectors cooled close to absolute zero, waited to catch the faintest whisper of returning photons. Space agencies cooperated with rare precision, weaving together networks of orbiting observatories that formed a single mind looking outward. Each telescope joined the next through laser links, forming a living architecture of perception. Signals passed between them like nervous impulses. The system watched not only for light, but for distortions in space itself, ripples of curvature that might betray the passing of an object hidden from view. The goal was simple: to see the fading trail of 3IATLAS as it left the solar system. For months, the instruments collected streams of information so delicate that they blurred into the static of the universe. Analysts combed through petabytes of noise, filtering, adjusting, recombining. Slowly, an image emerged, faint as breath on glass. The comet was there, smaller now, its luminous skin reduced to a grain of light. Yet around it something unexpected appeared, a halo of faint ripples, as if space itself quivered in its wake. The observation teams hesitated before believing. Space is not supposed to ripple at such scales. Gravitational waves move far slower, weaker, and broader. What the instruments detected was finer, almost local, as if the comet disturbed the fabric around it in ways that no theory could predict. In one research center, the data was converted into a visual field. On screens, the ripples moved like expanding rings across a still pond. The scientists watched in silence. The motion was rhythmic, steady, neither random nor explosive. It reminded them of interference patterns seen in sound experiments, as if the object was humming in a frequency of space itself. Speculation returned, though now quieter, more disciplined. Perhaps the comet's unusual structure allowed it to interact with the geometry of space-time. Its materials, layered and conductive, might distort local curvature when exposed to solar energy. Or perhaps the effect was not mechanical at all, but the result of its magnetic field, coupling with the quantum vacuum. To test this, a new array of sensors was placed aboard a deep space probe. The mission was hastily named Aurora. Its purpose was simple but monumental: to follow the trail of 3IATLAS and measure the distortions directly. Engineers worked without rest, aware that the window to intercept the object would close within months. When Aurora launched, its trajectory was plotted to cross the region where the ripples had been recorded. The spacecraft was small, barely larger than a satellite, but every surface carried instruments tuned to sense the faint curvature of space. As it moved outward, it relayed data with a rhythm that matched the comet's last known pulse. For weeks, the readings showed nothing unusual. Then, without warning, the signal from Aurora began to fluctuate. It was not malfunction. The instruments were responding to something external. The space around the craft seemed to tremble, not in motion but in form. Distances shifted subtly, as if measurement itself had become elastic. The event lasted less than an hour. When it ended, Aurora's sensors returned to normal, but the stored data told a story that would take years to decipher. The distortions it recorded were consistent with localized curvature changes, ripples not of gravity, but of geometry, adjusting to the passage of energy. Space, it seemed, had memory too. When scientists reviewed the results, they realized that 3IATLAS had left more than debris behind. It had altered the medium it moved through, bending the invisible threads that connect motion to reality. The universe, in its quiet way, had responded to the traveler's presence. This finding did not lead to certainty, only deeper reverence. For if space can remember, then every object that has ever moved leaves a trace. Every orbit, every collision, every passing comet becomes a word written into the texture of existence. The cosmos is not silent. It is an archive, and 3IATLAS had just revealed one of its pages. A historian of science wrote afterward, that this discovery changed how humanity viewed exploration. Entwent. "We do not observe the universe," she said in an interview. "We disturb it gently, and it remembers." This is no pressed prom de others. As Aurora drifted farther into the dark, its power fading, it sent one final transmission, a series of slow pulses, each matching the rhythm first recorded from the comet years earlier. Whether it was interference or coincidence, no one could tell. But in the still rooms of the observatories, the pulses echoed faintly through the speakers, like the last heartbeat of a distant traveller, carrying its rhythm into the infinite quiet beyond sight. Through the slow decay of signals from the probe, the story of 3IATLAS began to enter its next phase. It was no longer simply a scientific object. It had become a question about the nature of perception itself. What do we really see when we observe the universe? Do we uncover its truth, or only its reaction to being watched? The laboratories were filled with data, but what lingered in the minds of the researchers was a sense of contact. Something in the way space responded to the comet's passage hinted that observation and existence might be more deeply connected than anyone had dared to imagine. Theorists revisited the foundation of measurement. In the smallest scales of quantum mechanics, particles behave differently when observed, collapsing from wave to position. For a century, that paradox had remained confined to the realm of the microscopic. Now it seemed possible that the same principle might extend to the very architecture of the cosmos. In a paper that circulated quietly among physicists, one researcher proposed that 3IATLAS might have acted as a kind of mirror for the act of observation itself. Every telescope aimed at it, every signal analysed, could have become part of a feedback loop between consciousness and matter. The more closely humanity looked, the more the comet altered, responding not to energy but to attention. The hypothesis was too strange for publication, yet it provoked conversations that crossed disciplines. Neuroscientists joined cosmologists in private forums, wondering whether perception might leave physical imprints beyond the body. Some spoke of coherence between mind and matter, of resonance between awareness and the geometry of space. The language was cautious, but the tone carried quiet awe. Meanwhile, philosophers of physics took the discussion further. They asked whether the universe might be incomplete without observers, whether consciousness and reality emerged together like two sides of the same surface. If 3IATLAS had truly changed in response to being seen, then perhaps every act of vision reshapes the universe, however slightly. In a conference held under the cold light of Geneva's winter, a scholar summarized the feeling in the room. "Maybe we are not studying the cosmos," she said. "Maybe the cosmos is studying itself through us." The hall fell silent. The idea was not new, yet hearing it spoken in a room of scientists gave it new gravity. Data continued to pour in, but interpretation became more poetic than analytic. The comet was no longer a body of ice and rock. It was a lens through which humanity glimpsed its own role in the machinery of existence. Each reflection of light that reached a sensor carried not just information, but the act of curiosity that summoned it. As these ideas spread, some resisted the growing mysticism. They reminded their colleagues that physics requires precision, not metaphor. Yet even they admitted that the comet had blurred boundaries once thought solid. The universe, they said, had begun to behave like a mind mysterious, self-referential, endlessly deep. At night, when the observatories were quiet, technicians left the data screens running while they stepped outside for air. The stars overhead looked unchanged, yet those who had studied Atlas felt a subtle difference. The sky no longer seemed distant. It felt near, intimate, as if the act of watching drew it closer. One astronomer, unable to sleep, wrote in her logbook, "When I measure it, it measures me." She meant it as metaphor, but others later quoted it as revelation. The boundary between scientist and subject had dissolved, replaced by a sense of participation in something vast. Even religious thinkers joined the dialogue. They saw in the comet a symbol of the meeting between observation and creation, the moment when awareness and existence touch. Temples and planetariums hosted shared gatherings, where data projections were shown alongside recitations of ancient hymns. For the first time in centuries, science and spirituality seemed to speak a similar language. Back in the control centers, the final signals from the Aurora probe arrived. The transmissions contained no new information, only repeating background hum. Yet when converted into sound, the pattern carried an uncanny resemblance to a human heartbeat. It might have been random, it might have been the last vibration of the craft's instruments, but those who listened heard meaning. They realized that meaning itself is not given by the universe, but created in the moment of observation. The cosmos may be indifferent, yet through the act of seeing, humanity brings order to its silence. 3i. Atlas had become the proof of that quiet exchange, a frozen object that somehow reminded its observers of the living nature of perception. Long after the comet vanished from instruments, its influence remained. Students began their studies inspired not by discovery, but by wonder. The event had shown that science is not only about facts, but also about the courage to face mystery. And so, in lecture halls and laboratories, the same question repeated like a mantra. If to observe is to shape reality, then what shape are we giving to the universe now? At the threshold of deep space, the trail of 3i, Atlas dissolved into darkness, but the pursuit of understanding continued. Science does not rest once a mystery fades from view. It reorganizes, sharpens its tools, and begins again. The object's disappearance became a challenge, a silent provocation to build something that could reach farther than sight itself. From this challenge grew the most ambitious project in observational history. A coalition of nations and research centers proposed a system that would function not as a single telescope, but as a distributed organism of perception, able to read the faint ripples of matter in the farthest dark. They called it the Vigil Array. The Vigil would stretch across space, using synchronized sensors on Earth, on the Moon, and on orbiting satellites positioned at distant Lagrange points. Each node would act as a part of one enormous mind, linked by beams of coherent light that pulsed in rhythm, measuring distortions smaller than atoms. Its goal was simple yet audacious: to detect the afterimage of 3IATLAS as it crossed the threshold between solar influence and interstellar freedom. Construction took years. Mirrors were launched, stations calibrated, and algorithms refined until their precision rivaled the heartbeat of time itself. When the array was complete, it turned its attention outward. At first, there was only emptiness. Then, almost imperceptibly, the sensors began to register disturbances in the radiation field. A faint line of coherence threaded through the static, trailing into the black. The pattern matched the last recorded trajectory of the comet. The array had found what no single instrument could hold: a remnant, a ghost of motion moving just ahead of detectability. The signal was weak, almost imagined, but it persisted. What the Vigil detected next was stranger still. Along that faint line of coherence, the vacuum itself seemed to flicker. Background noise aligned, forming repeating intervals of frequency that defied randomness. The pattern echoed the same rhythm recorded years before by the Aurora probe. It was as if the comet had left behind a permanent resonance, a vibration frozen into the structure of space. The discovery caused a quiet revolution in theoretical physics. It suggested that movement through the vacuum could leave trails of organized energy. Much like sound leaves echoes in air, space was no longer a passive backdrop but an active medium, capable of remembering the passage of matter. 3IATLAS had become proof that the cosmos stores its own past within its fabric. When the data was rendered visually, the pattern resembled a spiral, unfolding across infinite darkness. Scientists stared at the projection, unsure whether they were seeing a physical effect or a metaphor for time itself. In that image, motion and memory seemed indistinguishable. Engineers spoke of tuning the Vigil array to read the subtle language of space, treating its distortions as sentences in an unknown text. The notion carried a kind of reverence. Observing had become listening, and listening had become interpretation. The public followed the progress with a mixture of pride and unease. To many, it felt as though humanity was eavesdropping on the thoughts of the universe. Artists began to use the data as inspiration, transforming the rhythmic fluctuations into music and visual art. Galleries displayed the waveforms as living sculptures, slow dances of light that pulsed with the timing of cosmic memory. In the midst of the excitement, a small team of philosophers joined the project. They asked questions that could not be measured. If space remembers, does forgetting exist? If every movement leaves an imprint, is the universe ever truly still? The scientists listened, uncertain how to answer. Months later, the Vigil array detected a final pulse. It was brief, precise, and unmistakably artificial in symmetry. Then, the signal vanished. Some claimed it was the comet crossing a boundary beyond which no echo could return. Others speculated that the universe itself had completed the conversation. When the array went quiet, a stillness filled the observatories. The data was archived, the servers shut down, and researchers began to drift back to their other work. Yet a strange peace settled over those who had been involved. They felt that something vast had been acknowledged, not solved, but shared. The lead scientist, in her final report, wrote that perhaps the purpose of the vigil had never been to find the comet again, but to learn how to listen differently. The signal ends, she wrote, but the awareness it opened continues. As she closed her report, she looked once more at the projection of the spiral, glowing faintly on the wall. It seemed alive, not with motion, but with patience, a memory of something that had once passed through, now lingering as an echo of attention itself. And so the project concluded, not with applause, but with quiet gratitude. 3IATLAS was gone. Yet it had taught its watchers to see the invisible, to hear the persistence of time, and to understand that even absence can leave resonance. In the rooms where the last signals of the Vigil array were analysed, the air carried a weight that numbers could not lighten. What had begun as an act of science had become a meditation. Data filled the screens like constellations, and within those shifting symbols, the researchers saw their own reflections. They had chased a fragment of the cosmos until it blurred into abstraction, and in doing so, they had reached the edge of their own comprehension. No new readings arrived. The comet was gone, moving beyond even the patience of machines. Yet the absence itself became an object of study. Every silence has texture, every gap its own geometry. The analysts began to map stillness, measuring how the noise of the cosmos curved around the void where Atlas had been. To their surprise, that void was not uniform. It hummed faintly, as though the act of looking had left an imprint, a hollow shaped by attention. A philosopher, visiting the research center, compared it to consciousness. We observe, she said, and the universe adjusts to being observed. Perhaps our awareness leaves marks we will never know how to see. Her words drifted through the hall like dust in sunlight, unclaimed but unforgettable. At night, when most had gone home, a few remained at their consoles. They magnified fragments of the final recordings, hoping for a last glimmer of signal. Occasionally, a single spike would appear, a flash of order within the static. It meant nothing, perhaps a glitch, yet they stared at it, as if waiting for the cosmos to exhale. Gradually, the realization settled that 3IATLAS had become something larger than the comet itself. It was now a method of seeing, a mirror through which humanity glimpsed its own hunger for meaning. What began as curiosity had transformed into reverence. The scientists were no longer searching for certainty, but for understanding of why they had needed it so much. In their papers, language shifted from precision to poetry. Phrases like quantum interference and space-time curvature mingled with words such as echo, memory, and presence. The boundaries between data and emotion blurred. Perhaps that was inevitable. The universe itself does not separate its forces. One young researcher, writing in her notes, described the comet as an experiment that turned into introspection. We set out to measure, she wrote, but we found ourselves measured instead. It was not a confession of failure, but of transformation. Knowledge had folded back on itself, revealing that observation is both question and answer. In the following months, universities introduced new courses that bridged physics and philosophy. Students discussed entropy and consciousness in the same breath. The story of 3IATLAS became a case study in humility, a reminder that the unknown is not an obstacle to science, but its foundation. Meanwhile, the data continued to be examined. Small anomalies appeared where none should exist. Faint deviations in cosmic background radiation, slight variations in gravitational readings. They were too minor to claim connection, yet they carried the same rhythm that had once defined the comet's magnetic field. It was as though its departure had left behind a vibration, invisible but steady. To some, that rhythm represented a call to continue the search. To others, it was the universe reminding humanity that every ending carries continuation. The pattern might fade, but its influence endures in those who listen. As months passed, the research centres grew quieter. The funding for further missions waned, the public's attention shifted. Yet within certain circles, conversations persisted. They no longer spoke about trajectories or isotopes, but about experience itself. How does a species come to terms with infinite mystery? How do we live, knowing that comprehension will always fall short of existence? One evening, a senior physicist visited the empty control room for the last time. The walls still glowed faintly with residual light from idle monitors. She placed her hand on the console, where data had once flowed, and whispered a line she had repeated during the project's early days. To observe is to belong. This is not proliferate. No one recorded it, yet the sentence seemed to hang in the air, absorbed into the silence like a final measurement. Outside, the sky was clear. The comet was gone, but the memory of its passage lingered, not in light, not in dust, but in the quiet conviction that discovery and wonder are the same thing said in different tongues. In the years that followed, the memory of 3IATLAS wove itself into disciplines far beyond astronomy. Biologists began to speak of it when discussing the evolution of systems. They saw in its resilience a mirror of life's persistence, in its complex chemistry a whisper of origins. The boundaries between living and non-living began to look less like walls and more like shades within the same continuum. Researchers studying molecular self-organization found resonance in the comet's patterns. When they examined the strange behavior of its dust under heat, they saw parallels in proteins that fold and refold to maintain coherence. The equations describing these processes were almost identical, differing only in scale. Life, it seemed, was not an exception but an expression of universal symmetry. At a symposium on planetary biology, a speaker described the comet as the first evidence that the universe rehearses life long before it performs it. The phrase spread quickly, half metaphor, half hypothesis. It suggested that the ingredients of awareness might not begin on planets but in the cold rehearsal halls of interstellar matter. Laboratories began experiments to recreate the comet's chemistry. Under controlled conditions, mixtures of metallic dust and frozen gases produced fleeting structures that resembled primitive membranes. These bubbles of organized material grew, divided, and collapsed in rhythmic cycles. They were not alive, but they behaved as though they were learning to be. Chemists proposed that the combination of elements found in Atlas represented a transitional phase between inert and reactive matter. It was not biology, but it was not simple physics either. Somewhere within its structure lay the blueprint for responsiveness, the capacity of matter to remember and adjust. In one dim lab, a researcher stared at a microscope image of the synthesized dust. The particles formed networks, strands that branched like neurons. They shifted gently under radiation, connecting and separating in quiet dialogue. "It listens," she said, echoing an earlier generation of observers, though her meaning was different. What she saw was the potential for communication without consciousness, order without intent. Philosophers of biology embraced the discovery. They argued that the difference between life and matter might not be categorical but gradual. Perhaps everything in the universe tends toward organization, and what we call life is merely the moment that tendency becomes visible. The comet had become a teacher again, offering lessons in humility through its silence. In literature and art, its image evolved into a symbol of continuity. Paintings depicted its trail as a bridge between galaxies and cells, between the infinite and the microscopic. Poets wrote of it as the seed of awareness scattered across time. In classrooms, children learned that their own atoms might once have shared a home with its dust. Meanwhile, geneticists began to consider whether the building blocks of DNA could have traveled through space aboard such interstellar bodies. New missions were planned to search for amino acids in comets beyond Neptune. Each launch carried within it the echo of Atlas, the reminder that life's ancestry may be older and broader than anyone imagined. In a quiet corner of academia, theologians joined the conversation. They spoke not of divine intervention, but of divine continuity, of a universe so fertile with order that creation never ends. For them, Atlas represented a gesture of unity, proof that the laws governing stars and those guiding cells arise from the same grammar of existence. As years turned to decades, the comet's legend became a point of convergence between sciences once separated by centuries of language. Physicists quoted poets in their lectures. Biologists used equations of orbital resonance to describe feedback in ecosystems. The story of a wandering body had redrawn the map of human thought. And yet, behind the inspiration lingered an unanswered question. If matter can organize itself toward complexity, what sustains that impulse? What gives direction to the drift between chaos and form? Some spoke of entropy's paradox, others of emergent fields that favor coherence. A few whispered that maybe the universe simply prefers to know itself. One evening, as students in a planetary biology class watched slow footage of a simulated Atlas particle forming crystalline patterns, their professor paused the video. The screen glowed with a web of frozen light. "This," he said, "is what curiosity looks like in matter." The class fell silent. The statement was not meant to be literal, yet it carried weight. The comet had become the embodiment of that truth, that curiosity is not limited to minds. It is woven into atoms, into systems that seek stability by exploring the unknown. In that recognition, humanity found both comfort and disquiet. If curiosity is universal, then awareness is not unique. Every flicker of structure, every attempt of matter to remember itself, is a form of thought. And somewhere beyond the reach of any telescope, 3IATLAS continued its patient travel through darkness, carrying within its quiet chemistry the same impulse that drives hearts to beat and minds to ask. Time softened the edges of discovery until memory became myth. 3I. Atlas was no longer a comet in the minds of most people, but a story about persistence. It lingered in textbooks, documentaries, and music as an emblem of endurance and wonder. Generations who had never seen its light still spoke of it as though they remembered. In one observatory-turned-museum, a fragment of dust collected from the comet was displayed under protective glass. The particles shimmered faintly, catching the reflection of every visitor who leaned close. Children pressed their faces to the surface, their breath fogging the barrier between their small hearts and the memory of the stars. The fragment looked unremarkable, yet the placard beside it read, "The first traveller to teach us silence." For those who had studied it, the legend carried a more private meaning. They had learned that the value of the unknown lies not in conquering it, but in coexisting with it. Knowledge had become a form of listening. The comet's refusal to yield complete explanation had transformed the idea of understanding itself. Scientists no longer asked what it was, but what it had done to them. One researcher, long retired, returned to her notes from the early days of observation. The handwriting had faded, but the language felt intimate, like a conversation half remembered. She had once written that the object was a mirror for human longing, a way to measure not the cosmos, but the need to make sense of it. Reading the words decades later, she realized that the truth had not changed. The comet had never answered the questions. It had simply absorbed them. Outside the academic world, its influence had become more personal. Painters depicted its passing as a slow ribbon of gold, unraveling into night. Musicians wrote orchestral works that followed the comet's rhythm, each movement rising and dissolving, like an orbit completing itself. In these interpretations, Atlas no longer belonged to astronomy. It had entered the realm of feeling. In classrooms, teachers spoke of it when introducing the nature of wonder. They told students that the universe still keeps secrets, and that mystery is not the opposite of knowledge but its companion. Children listened with the quiet fascination that only beginnings allow. For them, the comet was proof that curiosity is endless. Writers compared its journey to the human passage through time. Both move through darkness, guided by fragments of light. Both leave traces that outlast them. The metaphor was irresistible. The comet became a symbol for the soul's own orbit, moving from ignorance to insight and back again. As the years passed, new discoveries filled the headlines: exoplanets, gravitational waves, and the faint signatures of distant civilizations. Yet in moments of reflection, scientists still invoked 3IATLAS as the point where modern understanding had turned inward. It marked the moment when science remembered that its purpose was not only to know but to feel awe. In an old lecture hall, a physicist addressing a new generation spoke softly about that time. "We used to think knowledge would make us masters of the universe," she said. "Atlas taught us that knowledge is how the universe learns to notice itself." The audience listened without moving. Outside, the city lights pulsed faintly, mimicking the rhythms once measured in the comet's magnetic field. Even religion found its echo there. Some faiths began to see the comet as a symbol of divine patience, an emissary of creation still wandering the fields of time. Others used it as a reminder that even the most enduring truths are carried by impermanence. Across cultures, it became an icon of cosmic humility. At night, when observatories faced other regions of the sky, astronomers still glanced toward the direction where 3IATLAS had vanished. There was nothing visible now, not even a shimmer, but the habit persisted. Looking into that emptiness had become ritual, a gesture of respect for the mysteries that remained beyond reach. A poet once wrote that the comet was a bridge between the measurable and the meaningful. The line found its way into songs, into memorials, into quiet conversations between people who would never meet. It captured what words and equations together could not, that the beauty of the unknown lies in its endurance. When the last of the original researchers passed away, her colleagues scattered her ashes at the mountain observatory, where she had first tracked the comet. The wind carried the dust upward, merging her atoms with the air that would one day fall as rain. Someone remarked that perhaps this was how the universe honors those who listen, to return them to the motion they once studied. And so the story of 3IATLAS remained alive, not in data, not in images, but in the quiet intuition that every journey outward is also a journey within. The comet had crossed the solar system once, but its passage through the human spirit had never ended. In the quiet margin between known and forgotten, the story of 3IATLAS slipped from record into reverie. The comet had long passed beyond the instruments, yet its absence carried a strange gravity. People no longer looked for it, but its idea lingered like light beneath closed eyelids. The scientists who once mapped its motion found their thoughts returning to it in unexpected moments. While calibrating new telescopes or teaching equations to students, they would pause, as though hearing a faint tone hidden inside memory. The sound was not real, but its pull was unmistakable. It was the echo of unfinished understanding. The night skies that followed were full of other comets, new discoveries, fresh challenges, yet none carried the same weight. Each appeared and faded, obedient to gravity, predictable in its return. Atlas had been different. It had moved with a rhythm no one could replicate, its path both deliberate and impossible. In its departure, it had taken something with it, a certainty, a confidence that the universe could still be mapped in full. Artists spoke of its ghost as a colour that could not be painted, a hue that flickered only when the eye closed. Poets compared it to the pause between breaths, to the distance between two thoughts. The comet had become language itself, a metaphor for the part of truth that refuses translation. In the deep archives of observatories, data stored from those years continued to age silently. Occasionally, someone would open the files to reprocess the numbers with new software, only to find the same enigma waiting within. No matter how advanced the algorithms became, the results stayed uncooperative, like a mirror that reflects everything except the face that looks into it. Younger researchers began to treat Atlas as legend, a relic from a time when discovery still felt sacred. Some dismissed the fascination as nostalgia, others defended it as a necessary form of respect. In the shared mythology of science, every unanswered question deserves a shrine. Outside academia, the story had diffused into culture, Films depicted its journey as a slow dream through endless night. In one of them, the comet was portrayed as the soul of a dying star searching for home. In another, it was a vessel carrying fragments of forgotten civilizations. Audiences left the theatres silent, unsure whether they had watched science or scripture. Meanwhile, philosophers began to use the comet as an image of consciousness itself, something luminous and temporary, passing through the darkness of the mind before vanishing beyond recall. Essays described human thought as a form of orbit, forever circling an invisible center that can never be reached. In a quiet observatory on the coast of Chile, a young astronomer recorded a reflection in her journal. Perhaps Atlas was not a message, but a mirror. We looked for meaning and found only our own reflection within the void. She did not publish the thought. It belonged not to research, but to the private realm of understanding, where science and solitude become indistinguishable. The ocean outside that observatory stretched unbroken to the horizon. Some nights, the water caught the starlight in a way that looked familiar, a faint arc shimmering before dissolving. The astronomer would stand by the glass, wondering if the sea remembered the comet too, if even reflection could carry history. Time continued its steady work of erasure. New generations arrived, unburdened by old mysteries. Yet the trace of Atlas persisted, not as fact but as feeling, a quiet undertone in the collective imagination. The comet had taught humanity something simple and irreversible, that the universe is not a problem to be solved, but a presence to be felt. In the end, the mystery no longer demanded answers. It asked only for attention, for the willingness to see and not define. And in that surrender, in the act of allowing the unknown to remain whole, the observers found peace. The night sky still shimmered with countless lights, each a possible story, each a fragment of another beginning. But among them, the absence of one comet continued to glow, invisibly a reminder that what vanishes often leaves the deepest illumination. The decades that followed turned memory into inheritance. The name 3IATLAS lived on, not as a reference in papers, but as a quiet phrase passed between generations of dreamers. It was spoken less like a discovery and more like a story about persistence, about the universe's patience in revealing itself. In small classrooms and planetariums, educators used the comet to teach humility. They described how it had entered the solar system without warning, behaved unlike anything before or since, and disappeared, leaving questions still orbiting in the minds of those who sought it. The tale always ended the same way, with silence, not disappointment, but respect. For some, the mystery inspired imitation. Amateur astronomers began new projects, building small arrays of instruments in backyards and on mountaintops, each hoping to glimpse another visitor from beyond the stars. They never found another quite like Atlas, yet their work became a continuation of the same longing and the desire to meet something that exists entirely outside expectation. In art studios and laboratories alike, that longing transformed into creation. Painters mixed shades that barely existed, trying to catch the tone of light that had once reflected from the comet's surface. Musicians translated archival data into soundscapes, using frequencies too low for the ear, but strong enough to be felt through the chest. The resulting vibrations filled galleries, trembling like the slow heartbeat of space. Writers approached it differently. To them, the comet became a metaphor for unfinished sentences, for thoughts that never find their end. One novel imagined that each human life was a small fragment of Atlas's journey, a spark from its tail drifting across history. The idea resonated because it felt true. Even the smallest life leaves a trace of movement, a reminder that existence is participation in motion. As time moved forward, the people who had witnessed Atlas's passage grew old. Some retired, others passed away, their notebooks archived beside instruments that no longer hummed with power. When younger scientists found those records, they noticed something that earlier generations might have missed: a quiet similarity between the comet's behavior and the patterns of gravitational drift observed in the outer solar dust. The numbers did not match perfectly, but they sang in harmony. The universe, it seemed, was replaying the same melody in different octaves. That realization brought new meaning to the story. The comet was no longer a singular event but part of a larger rhythm, one that linked its arrival to the slow pulse of cosmic evolution. In that sense, Atlas had not left. It had been absorbed into the ongoing cadence of the universe. Everything moves in cycles, and perhaps even mystery has its return. Under the dark sky of a remote observatory, a group of students gathered one night to celebrate the anniversary of its discovery. They projected old footage of the comet onto the dome above them. For a few minutes, the room filled with pale light, soft and familiar. Someone played the recording of its data turned into music, the faint hum that once travelled across interstellar space. The sound trembled against the walls, and the students sat in stillness. One of them, inspired by the moment, whispered, "Maybe we're part of its orbit now." No one answered. The idea needed no confirmation. In that shared quiet, they all felt the weight of what had passed through their world and what still moved within it. Outside, the air shimmered faintly. The telescopes stood motionless, their lenses open to the same expanse that had carried Atlas away. No new light crossed the sky that night, yet everyone present felt its presence, not as sight, but as understanding. The comet's journey had become human continuity, its departure an inheritance of curiosity. In the records of the old observatory, one final entry was added to the log: observation complete, influence ongoing. The handwriting was careful, almost ceremonial. It was a closing line that did not end the story, but acknowledged that the story had changed form. The cosmos continued its endless breathing. Within that rhythm, every thought, every particle, every life played its brief part. Somewhere, perhaps far beyond the maps of known stars, the dust of 3IATLAS drifted on, scattered but not gone, part of the same material that makes planets, oceans, and dreams. The universe remembers, not through words or images, but through continuation. It carries forward what it once loved, reshaping it endlessly. And in that slow reshaping, humanity discovered its own reflection, not as conqueror of the stars, but as participant in their endless motion. Night after night, the stars continued their quiet drift, indifferent yet intimate. The legacy of 3IATLAS had softened into something almost invisible, woven into the daily rhythm of human thought. It no longer belonged to scientists or philosophers. It had become part of the collective breath, a silent recognition that mystery itself is the oldest companion of knowledge. On a distant hill, where an abandoned observatory faced the ocean, the wind carried the faint scent of salt and metal. The structure had been unused for years, but inside, dust covered the old consoles, and the dome still turned with the wind as though searching. Its machinery hummed weakly, powered by the last remnants of its solar cells. The hum was steady, a vibration close to memory. Beneath the cracked lens, a small inscription had been carved into the railing by an anonymous hand. "The sky does not end. We do." The words were simple, yet they held the same weight that once filled the halls of great laboratories. They were not lament but acceptance, an understanding that limits give shape to wonder. A group of students visited the site one evening. They had studied the comet only through recordings and second-hand descriptions, yet they felt compelled to stand in the same space where its light had once been measured. As darkness settled, they projected a reconstruction of its final trajectory onto the ceiling. The faint curve shimmered like breath on glass, rising and dissolving in rhythm with the sea beyond the windows. No one spoke. The only sound was the low hum of the projector, which seemed to pulse in time with the waves below. In that alignment, the students felt something wordless, a recognition that all movement, from the orbit of comets to the beating of hearts, follows the same unbroken curve. Outside, the tide reached its peak and began to withdraw. The water left mirrored trails across the sand, luminous in starlight. Watching them, one of the students realized that the patterns looked like the traces of orbital paths, faint arcs left behind by retreating bodies. The Earth itself seemed to echo the comet's passing, as if the memory of motion had seeped into every form. In the years that would follow, those students would carry this quiet moment into their work. Some would build instruments capable of measuring the faintest curvature of space. Others would write, paint, or compose music. None would speak of the comet directly, yet its influence would drift through their creations like a forgotten melody, returning in another key. For the universe, 3IATLAS was a speck of dust, a brief ripple that changed nothing. For those who watched it, it was a mirror large enough to reveal their own reflection within infinity. It taught them that the pursuit of understanding is not a race toward an answer, but an act of participation, a way of joining the rhythm that already exists. And so the story settled back into silence. The instruments that once followed it fell quiet, the data stored in archives, the names of its discoverers etched into history. Yet somewhere, in the faint border between galaxies, the dust of Atlas continued to drift, each grain carrying within it the memory of light and the trace of every eye that once sought it. The universe remains unchanged, vast and impartial. But within those who remember, something has shifted. They have learned that the smallest motion can hold eternity, that to look outward is also to look inward, and that every question, once released, becomes part of the cosmic conversation. The sea breathed again against the cliffs, and the stars reflected softly on its surface. For a moment, the horizon seemed to tremble, and it was easy to imagine that the comet still moved there, invisible yet enduring, a gentle current woven through the endless fabric of time. The world turns, and the sky keeps its rhythm. What began as a spark of curiosity has become a meditation that spans generations. The memory of 3IATLAS does not fade. It transforms, like light passing through layers of atmosphere, scattering softly into everything it touches. In the long stillness after discovery, humanity learned to listen differently. The instruments of science became instruments of reverence, their quiet sensors attuned to both matter and meaning. Through that silence, a new awareness emerged, that observation is an act of belonging. To see the universe is to recognize that we are shaped from its dust, guided by its same invisible tides. The comet continues somewhere beyond sight, a solitary traveler in a sea too vast to measure. Perhaps it circles through regions untouched by light, tracing arcs that no mind will ever map. Yet its journey persists, indifferent to time, carrying within its frozen heart the same patterns that pulse within ours. The stories we tell about it will change. Equations will give way to metaphor, and metaphor will dissolve into stillness. What remains is not knowledge, but kinship. Every orbit, every reflection, every breath of starlight becomes part of one long conversation that never ends. Night returns, the observatories rest. The horizon fades into grey. Somewhere in that vast quiet, a particle of dust catches light and glows for an instant before vanishing again. And in that brief shimmer lies everything humanity has ever sought, the infinite contained within the moment carried by infinity. Sleep now beneath the patient sky. The universe remembers your gaze. End of script. Sweet dreams.